Hi everyone, can you hear me? Okay, just let me know if everything is good. Just let me know if audio and video everything is fine. Okay, we will start if you just confirm. Is everything good? Okay, so let's get started. Cool. So let's get started with this session. So let me just tell you that what we are going to do in this session and then we will start, right? Okay. So in this session, we are going to cover asymptotic notations, right? What are the different asymptotic notations? Big omega, little omega, these things, right? So we will cover all of these asymptotic notations with many examples. So here the asymptotic notations will be covered, and this will be kind of a revision and practice session. Okay. Okay. So let's get started. Just confirm if everything is fine. Okay, so let's get started now. So it will be revision and practice session for the asymptotic notations. Cool. If there is any issue, you can just let me know in between the class also. Okay. So these are the few notations that we have, which is big O notation, big omega notation, theta notation, little o notation, little omega notation. Okay. Some people call them small o. Okay. Some people call them small o also, small o notation, and here small omega. Okay. You can call that a small o or a small omega, doesn't matter. So it is fine. Like whatever you call it, it is definitely fine. Okay. Now let's get started. See, why we study this asymptotic notations. Let's suppose that let me first tell you that why we even need it, right? Why we need to study. Can anyone tell me that why we need to study this asymptotic notations? Asymptotic notations, right? So can anyone tell me that why we need to study this asymptotic notations? See, see. Let's suppose that you have one algorithm and then you want to check that how good or bad this algorithm is performing, right? So let's suppose there is one algorithm. Now, how you will check whether this algorithm is a good algorithm or a bad algorithm? How you will check it is a good or a bad, or what is the time complexity? Then you can say that we can run this. We can run this algorithm on a computer, right? Run this on a computer. So we can run this on a computer and see how much time it is taking, right? And see how much time it is taking. Now, is this a good way to check whether the algorithm is good or bad? Is this a good way to check? Just let me know. Okay, so definitely that's not a very good way, right? Definitely that's not a very good way. Why that is the case? Because that can lead to a different complexities. See, let's suppose you do this. Then is this a good way? Then definitely not. Let me just tell you why. See, the reason here is that let's suppose that this is me. Okay, this is me. This is you. Okay, this is you. Let's suppose that we have different computers. I have MacBook. Let's suppose. Okay, and you have, let's suppose, some Dell laptop. Okay, Dell laptop. It might be the case that this algorithm may be running better on my computer and may not be running better on your computer because the computers are different, right? Since the computers are different, so I cannot basically have the time manually, right? If we manually measure, then we have to measure on a same computer. That's the difficulty here. So the hardware should be same. If I want to just compare, right? Hardware should be same, which means let's suppose that you develop some algorithm. Okay, this is me and this is you, right? Let's suppose let's suppose you develop some algorithm and I develop some other algorithm. Let's suppose my algorithm is algorithm A, your algorithm is algorithm B, right? Now let's suppose that we want to compare which one is better. Let's suppose my algorithm is taking 100 millisecond. Your algorithm is taking 1000 millisecond. Then which one is better? See, it might be the case that I am running that on the MacBook, right? And which is, let's suppose, a better machine than your machine. Okay, let's suppose you are running that on the Dell laptop. Okay, some configuration is there, but let's not worry about it. So the idea here is that if we want to compare these two algorithms, algorithm A and algorithm B, then it is not straightforward if we just manually see, okay, which algorithm is taking how much time, because then the computer should be same, and it will be very difficult to do that in a long run, right? So that's why these kind of analysis are not preferred, because these are the platform dependent analysis, right? This is platform dependent analysis. So what is a better idea? Can you tell me what is a better idea than this? Okay, so the better idea could be, you can say that what we can do, we can basically have some platform independent analysis, right? We can basically have some platform independent analysis. So let me just tell you that what we can do here. Okay, what we can do here. Now what we can do, we can say, let's suppose we can say that if we have two algorithms to compare, then we can say let us just count steps, right? So let's count steps, which means for example I am doing something like this: for I equal to 0, I less than n, I plus plus. I am doing, let's suppose, something like this: sum plus equal to a of I or something, right? Then how many steps it will be taking? You will be just checking, okay, it will be taking n or n plus 1 or whatever, right? And then let's suppose someone else is doing something like this. Someone else is doing, let's suppose, something like this. Okay, they are using two for loops. Okay, for let's suppose something, and then for something, and then they are adding. Then basically, if you count the steps, then it is better, right? If we count the steps. So basically, asymptotic analysis is basically just to it is just there to make sure that you are not platform dependent. So that's why we have the asymptotic analysis, and then we can count the steps. But in counting the steps also, let's suppose someone is running. Okay, someone is running. Let's suppose from I equal to 0 to I less than equal to n or something. Okay, someone is running till less than equal to n. Then you will be like, okay, it is taking n steps. It is taking, let's suppose, n plus 1 steps or something like that. Then this plus 1 or minus 1, right? These things won't matter in long run. So that is why we have asymptotic analysis, which says that we can get rid of the details, which means we can get rid of this 3n square is same as n square in asymptotic sense. Okay, so basically we are rounding off, which means, let's suppose, if we have some number, then we can round off. It is just like a rounding off. So asymptotic analysis is basically counting steps, but rounding them, right? Rounding them. Is this clear to everyone? Let me know. Is this okay? Okay, great. So now let's just see the asymptotic analysis in a greater detail, right? Okay, so let's just continue now. Cool. So let's just first start with the asymptotic notation, which is big O notation. So here we use some notations from the mathematics, which are big O, small o, and these things. We will understand them very carefully. So let's suppose there is a function which is Tn, and we say that Tn and Gn are related by big O if Tn is less than or equal to C into Gn for some constant. There exists some constant, which means, see, let's suppose Tn is n square. Let's suppose Gn is let's suppose n cube. Okay, or let's suppose this is let's suppose 5n square. Okay, 5n square. Then can I say this Tn is equal to big O of Gn? Can I say this? Is this true or false? Just let me know. What do you think? This is true, right? True. Why that is true, you need to understand with the help of the definition. See, when we say this is true, whenever Tn is lesser than, see here, it is lesser than equal to C into Gn for some C and after some n naught, right? So this is saying for some C, which means, can you tell me that for which C it is C into Gn? So for which C it is lesser than equal to 5n square? Can you tell me? For which C? Can you give me some C? See, here, this comparison is not asymptotic comparison. This is general mathematics comparison, right? Mathematics symbol lesser than equal to symbol. So now you tell me in normal mathematics, when can n square be less than equal to c into 5n square? Maybe you can give me some c, right? So what is that c? C you can give me, maybe you can say it is 1 upon 100, right? Maybe you can give me some c. So this n square is less than equal to, sorry, here we want that to be lesser, yeah. So in that case, what could be the c? Here, this c could be 1, right? This c could be 1. If c is 1, then this is lesser than equal to 5n square, definitely, right? So c could be 1. Can it be 2? Yes, it can be 2. Can it be 3? Yes, it can be 3. So there has to be just one constant. Okay. So here, this n square is less than equal to c into 5n square. Why? Because at least there is one constant for which this is true. Can you tell me what is that c? So c here is 1 or maybe 2 or anything. So after some n naught also. So what is the value of n naught? See here that for some c there should be some graph. For some c it is greater after some point in time. See, for example, if I just ask you that which is greater, n square or 2 power n, then what you will say? That you will say that okay, for n equal to 1 both are same, right? For n equal to 1 both are same. Sorry, it is 1, it is 2. For n equal to 2 both are same, right? For n equal to 2 both are same. This is for n equal to 1, this is for n equal to 2. For n equal to 3, what is happening? This is 3 power 2, which is 9. This is 2 power 3, this is 8. So for n equal to 3, I think this is greater, right? So n equal to 3, this is greater, this is equal, this is greater. Now for n equal to 4, what is happening? For n equal to 4, this will be 16, and this is again 16, right? So both are again equal. But for n equal to 5, what is happening? This is 32, this is 32, this is 25. And now from now onwards, if you check from now onwards, this will be only greater. Okay, this will be only greater. So basically, if I just ask you n square is greater or 2 power n is greater asymptotically, then which one is greater? Then you will say that 2 power n is greater, right? Why that is the case? Because after some point in time, see, before some point in time, anything can happen. But after some point in time, for example, here n naught is equal to 5, right? After some point in time, only this 2 power n is greater than n square. And what is the value of c here? The value of c is 1, right? Or maybe 2 or anything you can take. So let's see more examples and then you will get to understand more. Can you tell me the value of c and n naught for the below functions? So for what value of c and for what value of n naught, right? You can say that this 3n plus 2 is basically you can say this is less than equal to c into n. For what value of c and for what value of n naught you can say this? Can you tell me? Yes, definitely, right? So here for c equal to 5 probably, right? For c equal to 5 you will say that okay, this is this term is less than equal to this term, right? This is normal mathematics term. Okay, for c equal to 5 you can say. And what is the value of n naught? Maybe you can have any large value, doesn't matter. So you can have 5 also, I think it will work, but you can have anything, right? 5, 10 or anything, right? So given this, can you also tell me that for what value of c and for what value of n naught, this will be true, which means this is less than equal to c into n cube. For what value of c? Maybe you can say for c equal to 1 only, and for n equal to maybe 3 or 5 or whatever, right? If it is 2, then it is 4 into. Okay, if it is n equal to 2, then it is 4 into 2, which is 8. If here this is 8, right? For n equal to 2, both are equal, I think. But you can say for n equal to n not equal to 3, right? For n not equal to 3, this will happen. So for n not equal to 3, this will happen. Now what I'm saying here is that if c equal to 1 and n not equal to 3, this will happen, right? Okay, so now you can tell me values of c and n naught for all of this case, for this case, this case, right? You can definitely tell me. Okay, great. Now let me just ask you for this one also. So what is the value of c? So let me just write it in this way. What is the value of This is 2 power n, right? C such that this is true, maybe for C equal to 5 and for n not equal to anything, right? For n not equal to 10. So you can definitely tell me the values of C and n naught. Okay. But here is a good news. The good thing is that we never, okay, this is just for the understanding, but we never need to find values of C and n naught in questions. Okay, I mean that is just a definition, but we don't need to do it. Okay, we will see the questions and we will see that we never need to find the values of C and naught. See, those who have already studied, then can you not tell me that this is true without even worrying about C and n naught? Can you not tell me this is true, right? Because this is a greater function, so you know this is a greater function, then this is true, right? So those who have already studied, can you not tell me that this is true? Because this is a greater function, so this is also true. So you don't need to find out C and not like that. You can directly compare. We will see. We will see how. Okay, you don't need to find out in the questions. Okay, now let's just see big omega notation. So big omega notation and big O notation both are similar. Here the only difference is greater than equal to. Earlier we were having less than equal to, which means we are saying that after some point in time, okay, after some point in time, see, if we are saying Fn is big omega of Gn, okay, big omega of Gn, then what does this mean? What does this mean? It means that after some point in time, Fn is greater, okay? After some point in time means this is called turning point. This is called turning point, okay? So after some point in time, see, before that anything can happen. After some point in time, Fn will be greater than or equal to Gn, okay? Or very specifically C into Gn. Okay, so there has to exist some C for which this is true. Let's just see the questions, and from that you will get to understand more. Okay, so before that, let's just have a fun question. So can you tell me what is the time to go from Jaipur to Delhi? Which option is correct? At least 1 minute you will take or not, right? Until and unless you can hack the time. So obviously you will take at least 1 minute or at most 1 year. So which one is true here? Okay, this is just a fun question. Can you tell me which one is true? At least 1 minute or at most 1 year? Or both are true? Let's suppose this is MSQ. Then can you tell me which one is true? I think both are true. At least 1 minute you will definitely take. At most 1 year you will definitely take. So if someone asks you that what is the time to go from Jaipur to Delhi, then you will say both, right? You will say both. So which means if I say, see, the time to go from Jaipur to Delhi. So if I say that it is greater than or equal to 1 minute, it is greater than or equal to 1 minute, or it is less than or equal to 1 year, do you think it is really helping me? See, suppose if I give you something like this, okay? Suppose if I give you something like this, then do you think it is really helping me? Okay. Suppose if I give you something like this, is this information that it is greater than or equal to 1 minute? It will at least take 1 minute. It will at most take 1 year. Is this information helpful? So not much, right? Obviously not much. So that is why like we have one more notation, which is theta notation, which will tell me that what is exact, okay? What is the exact time? So which means here, if I'm saying greater than or equal to, then it means I'm using big omega notation. Here I'm using big O notation, right? See, if you get confused, let's suppose this is Tn equal to big O of Fn. And if you get confused that, okay, whether it is less than or equal to, whether it is greater than or equal to, then what is the way to remember? What is the way to remember that this translate to Tn lesser than or equal to Fn, right? I mean, ideally it should be C into Fn, but I'm not writing C, okay? So what is the way to remember it? You can remember like this, that in the big O, generally we write bigger functions, okay? Here it is a bigger function, okay? Generally it is a bigger functions. In a big O, it is a bigger function, which means which means in the big O generally we write order of n cube, right, or order of n power 4 like this, right? So these are the generally bigger functions. So that's how you can remember that, okay, in big O there's a bigger function, which means this fn is bigger. Okay, this is bigger. Okay, this is bigger. That's how you can remember it. Okay, I hope that will be fine, that how to remember this. Now if I just ask you that if Tn, okay, is let's suppose big omega of Gn, then what is your translation? What will you say? It is lesser than equal to or greater than equal to? Okay, let's suppose this is given to you, then this will translate to Tn should be greater than equal to, see, it is the opposite of what we have seen, right? So which means that if big omega is lesser than equal to, then big omega is greater than equal to. Okay, so that's how you can remember. See, ideally should be c into, okay, c into Gn for some c and after some n node, but I'm not writing that much, so I'm just writing like this. Okay, I'm just writing like this. Ideally it should be c into something. Okay, anyway, okay, I hope that is okay to everyone. Now as we have seen here that this greater than equal to or less than equal to, these things might not be much helpful in many of the cases, right? So that is why Nuth, okay, which is a popular and great scientist, Nuth has invented theta notation. Nuth had invented theta notation to stop you can say misuse of big O and big omega. Okay, he says that, okay, can you tell me the exact time? Okay, can you tell me the exact time which is given by theta, right? Which is given by theta. So let's just see theta. So theta is saying that if Tn is basically equal to theta of Gn, then it means it is lesser than equal to also for some C1. It is greater than equal to also for some C1. It is lesser than equal to also for some C2. Okay, so which means Tn is actually exactly equal to Gn in terms of asymptotic notation. So which means what? Which means that, okay, I do not have the graph here, but which means that for some C1, you can say that let's suppose this is your Tn, right? And this is your C1 into Gn. So for some C1, you can say for some C1 it is greater, C1 into Gn is greater, right? For some C2, okay, for some C2, after some point in time, you can say anything can happen, but after some point in time, C2 into Gn is lesser. So that's why if Tn is in between that C1 into Gn and C2 into Gn, then Tn is said to be theta of Gn. Okay, theta of Gn. Is this understood? So let's just see with the examples. Now, can you tell me it is theta of n or not? Can I say it is theta of n? Okay, let's not worry about the C1 and C2, these values, right? Isn't it the theta of n? Isn't it the theta of n square? Isn't it the theta of 2 power n? Isn't it the theta of n square? Why? Because you can just take the most significant term, right? And these two are asymptotically equal. Okay, these two are asymptotically equal. So what is the most significant term here? So we will see that most significant term here is n root n. Okay, we will see why. We will see it is little later that why n root n is greater than n log n. So we will see this. But yeah, so these are the thetas, right? Let me know if you have understood that how to write the theta. So theta is just a most significant term, right? Most significant term. So if you just write the most significant term, these are the thetas, right? Okay, these are the thetas. So I hope you understood. Now tell me which one is true. This Fn is n and Gn is n square. Then can you say Fn is order of Gn? So which one is greater? Obviously Gn is greater, right? So Gn is greater, right? Greater than or equal to Fn. So what you will say? You will say it is order. Yes, that is true. Is the Fn greater? Is the Fn greater for any chance, by any chance? No, right? Fn is not greater. Are they equal? No. The most significant terms are not equal. They are not equal, right? So that's why A is the correct answer here. A is the correct answer here. What about this? N square and 2 power n? N square and 2 power n? So this is the exponent function, right? Exponential function. Now, if you want to compare between two functions, let's suppose you want to compare between n square and 2 power n. Then how you can compare? If you want to compare between two increasing functions, so by default all the functions, okay, are the increasing only, until unless I say so. Anyway, this 2 power n is increasing, n square is increasing. So if you want to compare between two functions, then what you can do? You can take a log, okay, take log and then check. So here, if you take the log, then what will the answer? This is log of n square. This is log of 2 power n, right? Let's suppose I take the log base 2. Now listen carefully. After taking the log, what is happening? After taking the log, you are getting this one, right? So which is nothing but n. This is n. This is nothing but the most significant is log n. So which one is greater? N or log n? So after taking the log, you got to know that n is greater, right? See, let me just tell you that in between log n and n is strictly greater, okay? Always greater. N is always greater. Interestingly, not just that. Even if you put any power of n, okay, any. Hello. Yeah. Sorry. I think. Okay. I think I was not audible, right? Now I'm audible. Okay. So there was some audio issue. Now I think it is fine, right? Okay. Okay. So what I was saying that if you take log n, right, and if you take n, if you take log n and if you take n, so let me just tell you again. See, if you take log n and if you take n, then which one is greater? Which one is greater? Then n is greater. Okay. Why that is greater? We will just tell you in a while that why that is greater. Even if you put any powers, okay, for example you put any power of n. Let's suppose you put 50 and here you put, let's suppose, even 100, okay, even 100. Then which one is greater? Then also n power 50 is greater. If you put let's suppose if you put here log n power even 10,000, okay, and let's suppose just n, just this is just n, okay, then which one is greater? This is n log n power 1 lakh and it is just n, then also it is greater, okay. So even what I was saying here is that you put any power of log n and any positive power here, as long as this epsilon is greater than 0, doesn't matter what power you put here. Okay, let's suppose you put here 10,000, 1 lakh, 10 lakh, 1 crore, 10 crore, or whatever, right? 100 crore, whatever you put, it is always greater. Even though if I just ask you log n power 10, whatever number of zeros, okay? Let's suppose, and I ask you n power 0.00001, then which one is greater? Then also asymptotically, okay? Asymptotically, which one is greater? This is greater, okay? Asymptotically, this is greater. Okay, so we will see this why, but for now just take it, take my words, right? That this is always greater, that n power, any power is always greater. For example, if I say log n power k and here n power epsilon, then which one is greater? Then n power epsilon is always greater. Okay, n power epsilon is always greater. Understood? Okay. Now let's just go back to this. Now here they are asking n square and 2 power n. Now what you can do here, that if they ask you something like this, right? What you can do here, you take a log. Okay, you take a log, n square and 2 power n. You take a log, it will be log n, okay, 2 log n or log n, and it will be n. Then after taking the log, which one is greater? See, before taking the log, you don't know, right? Now you wanted to compare n square and 2 power n. Now before taking the log, here I am saying before taking the log, before taking log, you don't know, right? But after taking the log, let's just take the log, then what will happen? Then it will be log n and it will be n, right? It will be log n if you take the log, and it will be n only, right? Then which one is greater? After taking the log, this is greater, right? After taking the log, this is greater. So even after taking the log, this is greater, then before taking the log also it is greater. Why that is the case? Let me just tell you. See what I'm saying here is that, let me just explain you that why this log is working and so on. Okay, so maybe, see, first understand this, that why taking log is working. For example, I wanted to compare n square and 2 power n, right? I wanted to compare this, right? I wanted to compare this. Now just see here that why this log thing is working and why this might not work sometimes. Let's just see what is a log function. It is something like this, right? It is something like this, increasing function or something like this. Okay, so log is definitely an increasing function. Let's just forget about your asymptotic notations. You just tell me, let's suppose this is some number a, or maybe let's suppose this is 2 power 10. This is, let's suppose, 2 power 40. Okay, let's suppose this is a big number, 2 power 10, and this is 2 power 40. Now what is the log of this? If this is n, what is the log n? What is the log of this? This will be 10, I think. And what is the log of this? This will be, you can definitely tell me, this will be 40, right? Okay, so this is 40. Now can you tell me which one is greater among this 2 power 10 and 2 power 40? Which one is greater? Definitely 2 power 10 is greater. Sorry, 2 power 40 is greater. Definitely 2 power 40 is greater. Now this 2 power 40 is greater than 2 power 10. Now you tell me, after taking the log, which one is greater, 40 or 10? 40 is only greater, right? 40 is only greater. So before taking the log, it was greater, and after taking the log also it should be greater, right? See, what I'm saying here is that log cannot make it lesser value. See what I'm saying, that if that is greater, then after taking the log, see, if a is greater than b, then log a is definitely greater than log b in general mathematics. Okay, in mathematics. Is this okay to everyone? Okay, is this okay to everyone? Now in asymptotic notations also, let's suppose I want to compare a and b. Now what I can do, I can take a log. Okay, for example, n square and 2 power n. I can take a log. If you take the log here, it will be log n. I mean 2 log n, but I'm not writing 2. It will be n. I mean it should be n. See, it should be n log 2 and 2 log n. But I'm not writing the constant, so ultimately it is log n only. It is n only, right? Okay. Now you tell me between log n and on n, which one is greater? Obviously n is greater. So if n is greater, then after taking the log, you got to know that n is greater, right? After taking the log. So this is after taking log, we got to know that n is greater than log n, right? After taking the log, we got to know, let's suppose this is a function a, this is a function b. So after taking the log, we got to know that log b is greater than log a, right? Log b is greater than log a. See, what does log do? Log b is greater than log a. What does log do? It suppress the value, right? It basically it is changing the scale basically, right? Changing the scale. So earlier I was comparing between 2 power 10 and 2 power 40. Now I'm comparing 10 and 40. After taking the log, I got to know, okay, these two are I mean, in between these two, this is greater. Now, obviously, before taking the log also, it must be greater, isn't it? See, log is even suppressing the value. So if after taking the log, asymptotically, if this is greater than before taking the log also, then this is greater, which means if I got to know that this log a is greater than is or lesser than log b, then what does this mean? Asymptotically, I'm writing it asymptotically, okay? Asymptotically. See, I got to know asymptotically this is greater. Then what does this mean? A is definitely lesser than B, right? Is this understood to everyone? A is definitely lesser than B. Okay. So here, after taking the log, I got to know that, okay, even after taking the log, see, log is basically changing the scale, right? Log is changing the scale. So even after taking the log, I got to know that, okay, this is this particular term is greater. Then before the log, it must be too far, right? It must be too far, isn't it? Now just see here that if you want to, let's suppose if you want to compare n square and n cube, then what you can do? You first take the log, right? You take the log here. Now suppose you take the log, then what it will be? It will be 2 log n. It will be 3 log n, right? It will be 3 log n. So asymptotically, I'm just writing it is log n. It is also log n, right? So after taking the log, you seem like that after taking the log, let's suppose this is function a, this is function b. So after taking the log, the both are equal. Then what does this mean? See, after taking the log, you got to know that log a and log b are equal. Can you say that a and b are also equal? Can you say this? That n square and n cube are equal? No, right? So here is a catch. Let me just tell you what is a catch. See, the thing here is that this is some function, this is some function. Now log is doing what? Log is just changing the scale, right? So after taking the log, they got too close that after taking the log, they're equal. Okay, I am saying that after taking the log, they're equal. But before taking the log, they might be far apart, right? So after taking the log, if you are saying that, okay, both are equal, then you can't conclude anything. So what I'm saying here is that if log a is greater than log b, what does this mean? It means that a is greater than b, right? Or maybe lesser also, okay? Which means if let's suppose log a is lesser than log b, then what does this mean? A is lesser than b. But suppose by chance after taking the log, you got to know that, okay, both are equal. Log a is equal to log b. What does this mean? Can you say a is equal to b? Can you say this? Then answer is no. Okay, answer is no. So here is a catch that after taking the log, if both are equal, then you can't say anything. Okay, you can't say anything. Which means if log a equal to log b, then tell me which one is true. Is a equal to b? Okay, asymptotically, I'm only comparing asymptotically. So ideally I should be writing theta. Okay, but I'm not writing it. Okay, I hope you understood. Equal means ideally I should be writing theta. Okay, equal means ideally I should be writing theta. Okay, so now suppose log equal to log b. Asymptotically I'm comparing, obviously. Okay, now you tell me, can I say a equal to b? Can I say a is greater than b? Can I say a is less than b? So we can't say anything, right? So we cannot conclude anything. No, we can't say this. Okay, we can not say anything. Why? Because it might be the case if both are equal. It might be the case earlier they might be too far. Okay, earlier they might be too far, right? Now they are too close that asymptotically they become equal. Now they're too close that asymptotically they are becoming equal. Okay, if asymptotically they are becoming equal, it doesn't mean that earlier also asymptotically they were equal. So we have seen some examples. See here we have seen the example. Now this n square and n cube, if you take the log, then asymptotically after taking the log, they are too close that they are equal. Asymptotically they are equal. But before that it was not equal, right? It was not equal. So I hope you understood this. Okay, so now we cannot say anything about this. So I hope you understood that log A equal to log b. If I say this, then here a equal to b, we can't conclude this, we can't conclude this, we can't conclude this, we cannot say anything. Okay, okay, so let's just see a toolbox that always works. So what you need to do, see what you need to do, you need to first cancel out the constants. So for example, or the ignore the constants. For example, if it is 3n square or something, then you ignore this 3 and so on, right? And you can ignore this 3 only when this is of this form, which means you can separate this from the function. Okay, so for example I ask you this. Can you ignore this? Can we ignore this too? What do you think? The answer is no. Why? Because currently I am not able to write it separately as a function. See, if I ignore this, then it is a major blunder. Why? Because see, you are not ignoring 2. You are ignoring 2 power n. You are ignoring 2 power n of function you are ignoring, right? Which you can't do it. Which means if you want to compare between n raised power n and if you ignore this, then you will say both are equal, right? Both are equal. But do you really think both are equal? No. This is greater, right? Because you are dividing by the function. We will see that later on that why that is greater. But yeah, this is strictly greater. So you cannot ignore this. Now you tell me, can you ignore this? Okay. Okay. Can you ignore this 3? Can we ignore this 3? So again, the answer is no, right? No. Why? Because if you ignore this 3, you are doing a major blunder. It is actually 5 power n. And let's suppose you ignore this 3, then you will say it is same as 2 power n. Right? Obviously both are not same. Both are not same. It is not 2 power n. So you can't ignore this. But now you tell me, if let's suppose, can you ignore this 2? Can we ignore this 2? Here the answer is yes, right? Here the answer is yes. Okay. Okay. So what is the toolbox that always work? You will say that, okay, see here that we will be ignoring if we can write in this form, right? And if log n is greater, then it is greater. Okay, if log n is lesser, then it is lesser. If log is saying equal, then we can't say anything. Okay, if log is saying equal, we can't say anything. Now coming back to the questions that we were solving. Okay, so now you tell me this 2 power n and 2 power n and this particular term which is n power n, which one is greater? 2 power n and s power n. Just think about it. Just think about it and let me know. Okay, this 2 power n and n power. See here, this 2 power n is basically, you can say after taking the log, it will be n only. It will be what? After taking the log, it will be n log 2, but I'm just writing n. It will be what? See, it is n log 2. It will be n log n. So it is nothing but n. It is n log n. So which one is greater? Obviously this is greater. So after taking the log, you got to know that this is greater. So that means that before taking the log also it is greater. So that's why A is the answer, right? A is the answer. Okay, here n square log n and n power n, see here, this is n square log n and this is n log n power 10. See, if there is something common, can you cancel something common? This is n square log n, this is n log n power 10. Can you cancel something common? Yes. So you can definitely cancel n, right? So it will be n log n, it will be n log n, this is log n power 10. Now you tell me, see, log n power anything cannot be just this n, right? Just this n. So that's why this is definitely greater. So what you can say? What you can say? This fn is greater. That's why B is the correct answer here. Okay, B is the correct answer here. Understood? Cool. Okay. Now can you just solve this particular question? N is power log n and 2 is power n. Which one is greater? N is power log n and 2 is power n. See, this is n is power log n. If you take the log, it will be what? It will be log n, right? Here it will be just n log 2. So as you notice that here this n is greater than log n power anything, right? So this is strictly greater. So after taking the log, this is greater than before taking the log also it is greater. Okay, so that's why A is the correct answer here. Right? A is the correct answer here. What about this? It is log base 2n and log base 10n. See, the base doesn't matter of the log, right? Why? Because it will be just a constant. So you can definitely convert log base 2n to any base, right? Which is basically, let's suppose, here log could be any base. So let's suppose log base 10, right? So you can definitely convert this. So if you want to convert to log base 10, then you can definitely do it. It is log base 10n and log base 10 2, right? And then you want to compare with gn, which is log base 10n. So this is fn, this is gn. So see here, this is constant. Since this is constant, that is why you will see that, okay, this fn is definitely equal to gn. So that's why C is the correct answer. If C is the answer, interestingly, if C is the answer, this is MSQ question. If C is the answer, which means A and B are definitely the answer, because it is already containing equal, right? If fn is equal to gn, right? I should be ideally writing C, or I mean C into gn, or maybe I should be writing theta basically. So if there is a theta, then if theta is there, then big O and big omega both are definitely there. So what is the answer? If this is see, it has to be MSQ question, then ABC all are the correct answer. It cannot be MCQ. Okay, it cannot be MCQ. If this is MCQ, then this will be marks to all. Okay, this will be marks to all. This cannot be MCQ, obviously. Understood? So that's why ABC are the correct answers here. Now, can you solve this? Okay, can you solve this? Let's just solve this. N is power log n, but here the base is 2 and it is in power. See, earlier I was comparing log base 2n and log base 10n. There it doesn't matter. There it doesn't matter what is the base. But if that is in power of n, then it will matter. Okay, it will matter. So if that is in the power of n, then it will matter. Now you tell me first, n cube is greater or n power 4 is greater? Yes. So in the log n and log n power 10, if something is common, you can definitely cancel out. Yeah, you can definitely cancel out log n. Okay, in the previous example, you can definitely cancel out log n, right? Okay. Now you tell me n is power n cube is greater or n power 4 is greater? No, definitely you will say that n is power 4 is greater, right? N is power 4 is greater. Okay. If I just ask you n is power, let's suppose 100 and n is power 99.99, which one is greater? So you will say again n is power 100 is greater, right? So which means if I just ask you n is power x is greater or n is power y is greater, where x is greater than y, then what you will say? What you will say? You will say whichever the higher power it is greater, right? The greater here means actually the comparison I am doing is asymptotic comparison. Okay, the greater here means the asymptotic greater. Although it is normal greater also, and for the normal greater also it is true. But here my intention is to have the asymptotic greater. Okay. Ideally I should be writing something like this, C into or something like this. But I'm just not writing C. Okay. Cool. Now, which means we have concluded that if the power is, if the power is greater, then that is greater, right? Now you tell me which one is greater here. N is power log base 2 is greater or log base 10 is greater? See, if you take the log, then what is happening? Then it will be log base 2n, log n, whatever base you have, right? again it will be log base 10n and log n. So if you take the log, then this will get cancelled out. It will be after taking the log, it is saying both are equal, because this is the log n. We have already seen that log n and log base 2 and base 10n both are same, right? Ideally both are same. So after taking the log, I'm coming with the case that both are equal. Then what we can conclude before taking the log? Tell me. So here what is happening? Here after taking the log, we got to know that both are equal. So can you tell me before taking the log what should be the case? See, suppose if log A is equal to log B, then can you tell me before taking the log? We cannot say anything, right? We cannot say anything. So I cannot say whether A is greater than B, A is less than B or something, right? I cannot say anything. Okay, nothing I can conclude. So basically using the log, it is actually not working. So what is the other method that we can use? So see here, we need to apply different methods. So if something is not working, then can you tell me what is the next method that will work? So maybe we can just compare the powers. Can you tell me this log base 2n is greater or log base 10n is greater? 10n is greater. Okay. Can you tell me? You can put maybe some n, maybe n you can put, let's suppose 2 power 10. Okay. So it will be 10. It will be approximately 3 point something, right? Because it is 2 power 10 is basically 1024. So here it will be 3 point something. It is 10. So if log base is 2, then it is seeming to be greater, right? It is greater. So which means this number is greater than this number. This power is greater than this power. So then what is the answer? So based on the power, can you tell me what is the answer? Answer here will be, if this power is greater, then Fn is actually greater, right? Fn is greater than equal to Gn, right? And in fact, it is not equal. It is actually greater, right? So it is greater. So that's why this A is the correct answer here. Sorry, if Fn is greater, then B is the correct answer here. Okay, so because this is big omega. Understood? So that's how you can solve this question. Okay. Now let's just see more questions. Okay, let's just see more interesting questions. So see here, if log A is greater than log B, then what you can say asymptotically? What you can say? A is greater than B, A less than B, A equal to B. What you can say? Tell me. A is greater than B, right? If log A is greater than, then A is greater than B. This is false, right? Okay. If let's suppose if I just ask you if both are equal, okay? If log A is equal to log B, okay? Let's suppose if I ask you if both are equal, then what you can say? Can you tell me? So suppose both are equal, then what you can say? Is A greater than B, A less than B, or A equal to B? What you can say? We cannot say anything, right? Okay, we cannot say anything. Good. Okay. Now let's just compare these functions, n into 2 power n and 4 power n. Which one is greater? Can you cancel out some terms here? See, one is n into 2 power n, another one is 4 power n. Which one is greater? Can you cancel out some terms? Can you divide by 2 power n both sides? It will be n. It is 4 power n divided by 2 power n, which is same as 4 divided by 2 power n, which is same as 2 power n. So it is nothing but n. You are comparing n and 2 power n. So definitely 2 power n is greater. So that's why you can definitely say that this is greater, right? This is greater. So which means that A is the correct answer. A is the correct answer. Okay. Now Fn is n square and Gn is n is power 100, n square log n. So now you see here, you can cancel out the common terms. It will be log n. It is n is power 98. So obviously n is power 98 is greater. Even n is power 0.000000001 is greater than log n. Okay, I told you this. So that's why this is greater. So that's why A is the correct answer here also. Okay, cool. Okay. Now let's just compare log n power log n and log n power log n. This was one of the TIFR question, if I remember correctly. This was one of the TIFR question. Can you compare these two? Okay. Can you compare these two? Just try doing it. See, if there is too much of log coming, maybe you can for example you can say that okay, for this particular question you can say that this n, okay, n you can assume to be 2 power k, because this is log n, so it will be, I mean, it is better you can assume n something, okay, just for the sake of solving this question. Or since it is 2 times log, it is 2 times log, so that's why we can assume it is 2 power k, okay, such that log n will be 2 power k and log n will be k, okay. So you can take n as some form, okay, we are taking n as some form. Now if you want to compare this log n, okay, so log n basically is 2 power k, power log n is k, this log n, this is log n, right, which is nothing but k, power log n is 2 power k. So basically finally you want to compare these two, right? Finally you want to compare these two. You can definitely write this 2 power k as 2 power k means 2 power k into 2 power k into 2 power k into 2 power k times, which is nothing but 2 power k square, right? See, if there is something like this, 2 power 3 power 2, okay, power 2. Can you not write this 2 power 3 into 2, which is 2 power 6, right? You can definitely write. But suppose it is like this, 2 power 3 power 2, okay. If this is 3 power 2, or maybe if there is no bracket also means by default it is coming from top, okay, by default it comes from the top, okay, for the exponent. Can you write it like this, 2 power 3 into 2? No, right? You can't write like this. So basically if it is in the bracket, then you can multiply these two powers, okay. If it is in the bracket, then you can definitely multiply these two powers. If it is like this, then you can't multiply, okay. Then obviously, because this is 2 power 9, not 2 power 6, okay, this is 2 power 9, not 2 power 6, okay. Now here this bracket, because of this bracket you can definitely multiply this is 2 power k square and this is k power 2 power k, okay. So basically I want to compare 2 power k square and there is another term which is k power 2 power k, okay, k power 2 power k. Maybe we can take the log now, okay. It will be k square, it will be 2 power k log k, okay, if you take the log. So obviously after taking the log, what you got to know, this is greater, then definitely before taking the log also this is greater, right? So which means this term is greater. Understood? This term is greater. So in like what is the idea of saying this of solving this question? Here I just want to convey that sometimes we can take the form of the log n, right? Okay, form of the n. So depending on the question, sometimes you might also take the form of the n. Cool. Now can you solve this? This is log n power 10 log n power 10. Okay, can you solve this? Maybe this is too much of log is coming. Let me just assume that log n is k. This is k, okay. Log n is k, which means it is log k. This is log k power 10. Okay. So which one is greater? See, this k power 10, let's suppose this is a, b, c, d. Obviously k power 10 is greater than all, right? Then a, then d, and then c, right? So this is the order. This is the asymptotic order. Understood? Okay. So here I assume that log n is k, or in other words you can assume n equal to 2 power k, but directly you can assume that log n is k. Okay, it is better because multiple log n's are coming. You can assume that log n is k. Let's see this question which I have taken from Stanford. Okay, let's see this question which I have taken from Stanford. So what this question is saying, recall that formal definition of big O is this, which means Fn is big O Gn if there exists a value of C and not such that Fn is less than or equal to C into Gn for n is greater than or equal to n naught. Okay, so they are saying that this is the formal definition, which means Fn is less than or equal to C into Gn if Fn is big O of Gn. Okay. For some C and after some n naught, then which of the following is true about this definition? Select all that apply. C and N naught cannot have the same value. Is there any condition that C and N naught cannot have the same value, or they can have the same value? Is there any condition in this definition? Have we seen any condition? We have seen that C could be 5, N naught could be 5, right? They can have the same value, doesn't matter. They can definitely have. So that's false. C and N naught must be integers. No, C could be 1 upon 100 or anything, right? No, it is not the case. If Fn is equal to Gn, then Fn is equal to order of Gn. Do you think this is true? See, this equal means that normal equal, until and unless in the questions are the always formal questions, okay? It's not like that that they can use any of the notation. So if they're saying equal, what does this mean? Is this normal equal or asymptotic equal? Are they, see, if Fn and Gn are equal, if in the question if they are saying if Fn equal to Gn, can I take, okay, in the question if they are saying this, can I take Fn as n square and Gn as 5n square? Are they equal? Tell me. Are they equal? So, are they equal? Obviously no, right? Obviously no. No, they are not equal, right? They are not equal. See, here this equal is not theta. Until unless they use the theta, you can't just assume the theta, okay? So here in our slides and our questions, I was just avoiding writing theta, and instead of writing theta, I was just saying they're asymptotically equal. But if they are saying directly equal, then it means both are exactly same. Both are either n square, both are either n cube or whatever, right? If both are exactly same, then obviously they are big O also, big omega also, theta also. So that's why this is true. Gn cannot be order of 1. Okay, Gn, no, it can be order of 1. It can be constant also. It is not the case. So no, none of them. So what is the answer? C is the answer. Okay, C is the answer here. Let's just see. So answer is C. This question I have taken from Stanford. Okay, basic definition question. Cool. Now let's just see this particular question which I have taken from NUS University. So what they're saying is that which of the following is the order of growth? Which statement on growth of constant function is true? Okay, is this true that can I write 100 equal to order of 0? Let's just check. What does this order of 0 mean? It mean that 100 I am saying equal to C into G of n, right? C into 0 basically, right? C into 0. Can I say that for some C, and basically it is not dependent on n, so let's not worry about n naught. Can I say for some C both are equal? C into 0. Can the 100 be C into 0 for some C? Sorry, this is less than equal to. Can the 100 be less than equal to C into 0 for some C? No, right? No. So 100 cannot be less than equal to 0, right? 100 cannot be less than equal to 0. So that's why this is false. What about this? Can the 0 be less than equal to, this means 0 is less than equal to C into 100. For some C, is this true? What do you think? For some C, is this true? Yes, right? Yes. 0 is definitely less than equal to C into, you can take C equal to 1. What about this? See, first of all, tell me, is this comparison asymptotic comparison or normal comparison? Is this an asymptotic comparison or normal comparison? This is a normal comparison, right? So we always, if there is asymptotic comparison, I will say it explicitly. Basically, instead of writing for n square n cube, instead of writing it like C into something, I just say it is lesser than equal to, okay? Until unless I say this is asymptotic, this won't be asymptotic basically, okay? So in this normal definition, these are the normal comparisons, okay? These are the normal comparisons. So this is a normal comparison. So this C, you can take C equal to 1. Tell me, can this 100 be equal to, or maybe for the theta, basically it means that it is less than equal to C into C1 into 0. And is this true? Tell me. Can the 100 be less than equal to 0 for any C1? No, right? So that's why this is false. Can the 0 be between this C1 into 100, C2 into 100? What do you think? Yeah, this is interesting, right? Can the 0 be less than equal to this? Is this true or false? What do you think? This particular statement, the 0 is basically less than equal to C1 into 100 and less than equal to C2 into 100. Is this true or false? For some C1 is this true? Yes, C1 equal to 0, right? For some C2 is this true? Yes, C2 equal to 0. So that's why this is true, right? This is true. This is true. What about this? All of the no. So B and D are the correct answer, right? Just a second. So this 0, see here they are saying 0 equal to theta of 100. So what is the definition of theta? What is the definition of theta? It says, okay, yeah. Interestingly, let's just see the definition of theta. So here you will notice one thing. See, let me just remind you the definition of theta. Okay, so they are saying there exists C1, C2 and N node such that this, right? Yeah. So if you are saying 0 equal to theta of 100, zero is less than equal to C1 into 100. So here this C1 can be 0, right? C1, C2. Okay. So if they ask you, if they say, let's suppose, see here, if they say 0 equal to order of 100, then what does this mean? Big O of 100, then what does this mean? It means 0 is less than equal to C into C1 into 100, right? For some C, this is definitely true. Okay. Now, if they are saying that so this is true, 100 equal to order of 0. So this is false. Why? 100 equal to order of 0. This is false. Why? Because 100 less than equal to C1 into 0. This is false. Definitely. But if they are saying theta, then what does this mean? It means 100. See here. So it means that if they are saying theta, so basically the definition of theta says, let me just go back to that particular slide. So it should be C2 into, I mean, some constant into this. So if they are saying theta, then we should be able to write, right? So I think we should be able to write. If that is the case, until and unless C1 and C2 greater than 0, we should be able to write. Okay, for some constants, 0 equal to theta of 100. This is C2, which can definitely be 0. And this C1, which can definitely be 0, right? So both can be 0. So I think this should be true. I think this should be true. Yeah. So this should be true. We will see this if there's a misprinting here. Okay. I mean, in the answer, if this is misprinting, we will see. Okay. So here it is given as only B. I will see. I think D should be true because for C1 and C2 we can take C1 as 0 and C2 also as 0, right? Both are 0. Okay. Cool. So Subham is saying, sir, how can we take C as 0? If we can take C as 0, then no matter which function we take, it will always be less. Okay, so let me just clarify this. See, let me just paste the definition from the standard resource. Okay, just a second, give me a second. Okay, okay. So as I can see from the Wikipedia, so basically the definition itself says. So let me just paste the definition. So the definition says that it should be. I'm taking the definition from the Wikipedia. These terms like this C should be greater than 0. Okay. So the definition itself. Let me just paste the definition. Okay. So actually the C should be greater than 0. So since C should be greater than 0, the K1, K2, these all these terms are greater than 0. Okay. So since all these terms, this should be greater than 0, should be greater than 0. So that's why we can't say this. Okay. So all of these terms should be greater than 0 actually. This C should be greater than 0. Yeah, that is a very nice finding that we have done, that this C should be greater than 0. Okay. So I have taken this definition from the Wikipedia. Okay. So this should be greater than 0. Now let's just solve this question. Now tell me, now let's just solve this question again. And now tell me, see what is happening here. Let's just see. So here, this is 100, right? So 100, can the 100 be lesser than equal to C into 0? For any C. For any C it is not true, right? For any C, not true, right? For there does not exist any C. So that's why it is false. Can the 0 be lesser than equal to C into 100 for some C? Yes, definitely. Yes, this is true. Can the 100 be lesser than or be lesser than equal to 0 into C2 and 0 into C1? Can this be true? So 100 cannot be lesser than equal to 0, right? So that's why this is false. Because of the later thing, this is false, right? Because of this thing, this is false. Now what about this? Here, this 0, I'm saying should be, see here. Let me just go to the next page. Okay. See, this 0 I'm saying should be in between of C1 into 100 and C2 into 100. Let's just see if this is true for non-zero C1 and C2. Okay. So C1 into 100 less than or equal to 0, lesser than or equal to C2 into 100. For non-zero, is this true? For non-zero, can this be true? For non-zero C1, is this true? No, right? For any non-zero C1, it cannot be true. Okay, I mean for non-zero and greater than 0. For any positive C1, is this true? No, right? However small you take, it is always greater than 0, right? So you can't make it true. So that's why this is false. Okay, that's why this D is false. Understood? Now, so that's why only B is the correct answer. Okay, because this K1, K2 or all of this here, as you can notice, all of this has to be greater than 0. Okay, in this definition has to be greater than 0. So hence only B is the correct answer. This is a good question. Okay, which is just asking you to know that what is the basic definition of these things, right? Okay, now let's just go to the next notation, which is little omega. Okay, now let's just go to this definition. See here, I have written C greater than 0, but earlier I forgot to write, but that's fine. So here, this little o, okay, a little o, and there is one more notation which is little omega. Let's just see these two notations. So what is happening here? Here we say that two functions, if they are strictly lesser, see earlier we were saying lesser than equal to, but if it is strictly lesser than C into Gn, then we say Tn is equal to order of, sorry, big O of little o of gn. Okay, tn is equal to little o of gn. Now you tell me, in between n square and n cube, can I say that n cube is strictly greater? Can I say n cube is strictly greater? Tell me. Yes, right? So that's why I can write little o. Okay, I can also write the little o. In between n and let's suppose log n, which one is strictly greater? N is strictly greater, right? So hence asymptotically I'm writing, hence log n you can write, if n is strictly greater, little o of n. Okay, this is a little o or a small o, whatever you want to say. Okay. Now interestingly, can you tell me in between n square and 5n square, in between n square and 5n square, can I say this 5n square is little o? Can I say this? Can I say this? Just tell me this. Can I say? See, let's just say if I say this, then what does this mean? It means that n square is strictly lesser than c into whatever is your function, 5n square. Is this true? Can you tell me some c for this is true? Can you tell me some c for which this is true? See, there are many c's, right, for which this is true. So c could be, you can take c could be 1. But does this mean that n square is small o of this? So here we need to hit the definition. Does this mean that n square is small o of this? Interestingly, no. Why that is the case? Even though we have found the c, still why we are not able to say? Because here the definition, I will check the definition again. I will show you the definition again. But here the definition says that the c, okay, whatever I am writing here, the c, this is not just for one c. This is for any c you take, any c. Here we do not need to just show one c. Okay, here just one c is not good enough. Here just one c is not good enough. Can you take any c and still it is true? No, right? Because here we need to find the counter example. Can you tell me for what c this is false? So definitely for c equal to, let's suppose, 1 upon 100, right? This is false. So that's why it is not true for any c. You understanding? See, just this definition. Just read this definition once more and let me know if you have understood. See what this definition is saying, that for any constant c, right? Just see this. Okay. Just give me a second. You just see this. Let me just plug in the charger. Okay, you understood that for any constant it should be true, not for there exist. Have I written there exist here? Is this there exist? No, this is not there exist. This is for any constant, right? This is for any constant. So that's why it become interesting that that if you go for this definition, then you should be telling me, is there any counterexample exist? Tell me. Can you give me any counterexample where this is not true? Okay, we are looking for the counterexample. Can you not give me the counterexample here? C into 5n square. For what c this is not true? Okay, so this is strictly lesser. This is normal comparison. Tell me for what c this is not true. Just tell me the counterexample. C equal to maybe 1 upon 100 or something, right? This is definitely not true. This is the normal comparison, right? This is the normal comparison. Okay, understood? So there are many c's for which this is not true. Now for example, if I just ask you, this is n square, this is n cube. Can I write small o? Let's just see. Which means n square is strictly lesser than c into n cube. Basically should be function lesser, okay? It should be function lesser. It cannot be equal. Now can you tell me some c for which this doesn't hold? No, right? So here in fact, if you want, you can just cancel out the term. Here it is 1 is lesser than c into n square. So the c into n, right? This is definitely 1 is definitely lesser than c into n. Okay, so there is no counterexample here, right? No counterexample. Now some people might say that if you take c equal to, let's suppose if you take c equal to very less, okay, let's suppose you take c equal to, you can't beat this n. That's the thing. If you, let's suppose c equal to 1 upon 10, something like this, right? 10,000, okay, or 10 lakhs or something like this, then after some point in time this will definitely dominate, right? After some point in time. So what point in time? Maybe n equal to 10 is power 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 10. Okay, after this point in time, this will definitely dominate. If you take very less c, you can sustain till some point only. Okay, if you take very less c, then that's okay, but you can't sustain after some point, because this will definitely start dominating. So here the n naught could be larger. That's the only difference that you are making. Understood? So here the definition says that there should be any constant. You plug in any constant. It doesn't say there exists. I hope you understood. Okay, so let me just ask you one example here. Okay, let me just ask you one example. So suppose they say, which of the following, let's suppose this is MCQ question. Okay, suppose they say, which of the following is correct relation in words if fn equal to small o of gn. Okay, then option A is saying that fn is less than c into gn for some c and n naught, right? Which means that after n naught this will hold, right? After n naught this will hold. And let's suppose some option is saying fn is less than equal to c into gn for any c there is a n naught for which it is true. Okay, for which this is true, right? Option C is saying fn is less than equal to c into gn for any c there is a n naught. And option D is saying, let's suppose option D is saying that fn is less than equal to c into gn for some c. Then what is the answer? See, this equal to is definitely straight away rejection. Okay, this equal to is not even valid. Then for any c, okay, not for some c. So that's why B is the correct answer here. Okay, this O is small o or little o or whatever you want to say. Okay, for every c it should hold. Understood? Cool. Now let's just see this question. Can you tell me this is true or false? Can this n factorial is strictly greater? Let's just take the log, right? Let's just take the log. If you take the log here, this is 2 power n, this is n factorial. If you take the log, then what will happen? This will be n log 2, right? This will be n basically, and it will be log n factorial. So which one is greater? So basically we will tell you that log n factorial exactly same as, which means theta, okay, is theta of n log n. Okay, I'm just skipping this theta. So basically this log n factorial, I will just show you in a couple of minutes, that log n factorial is same as n log n. So it is n log n, this is n. So which one is greater? Obviously n log n is greater. So after taking the log, this is greater. Then before taking the log also, it is strictly greater. So which means this is true. Okay. And I will just show you this, okay, that this is log n factorial and this is n log n. I will just show you this in just a minute. Okay, so let's just see the little omega. And then we will see more examples and many questions. Okay, so see here, the little omega is also same, that here also this is for any constant should be true. Okay, so if this is true, which means it is function greater, not just constant greater. Okay, if this is function greater, then you are doing Okay, if this is function greater, then this is related by little omega. Okay, now let's just see incomparatively also, which means there are some functions which may not be comparable to each other. Suppose if I ask you n and n is power 1 plus sin n, then which is greater? See, this sin n could be -1 to 1, right? This value range from -1 to 1. Then this, if I just tell you, see here, if I just tell you that this is n, this will be, let's suppose n, okay, sorry, this is, let's suppose n, then how does n is power 1 plus sin n will look like? N is power 1 plus sin n might look like this. Okay, maybe sometimes greater, sometimes lesser. So let's suppose n is power 1 plus sin n looking like this. So here, as you can see, that this function n is power 1 plus sin n, can you say it is definitely greater or definitely lesser than this n after some point in time? No, right? So you will say that this n, this is n, okay, this n is sometimes lesser or sometimes greater. So there are some functions which are incomparable. Okay, so for example, let me just give you one more example of an incomparable function. For example, if I just say fn equal to n square, and if I say gn equal to n if n is odd, or n cube if n even, are they comparable? Tell me. See, it is always n square, but sometimes if n is odd, it is n, it is lesser, sometimes it is greater. So that's why they are not comparable, right? Not comparable. Understood? They are not comparable. Okay. Now let's just see more examples, and then we will get to understand more. So these are some properties, that it is transitive, which means if two functions are related by theta, then if it is theta, then this is also theta, then obviously this will be theta, right? If these two functions are equal, then this will be equal. And similarly, if gn is greater than fn and hn is greater even than gn, then you can definitely see that fn is lesser than equal to hn. Okay, which means here they are saying that fn is lesser than equal to gn. Okay, and this is saying that gn is lesser than equal to hn, then definitely fn is lesser than equal to hn. Okay, cool. So there are some properties that we have. Now let's just see very interesting thing, which is n factorial versus ns power n, and log n factorial versus n log n. Okay, these are the two things that I want to just tell you. Okay, let's just see these two things. So here currently I'm not proving this, but here this n factorial is strictly lesser than ns power n. Okay, strictly lesser, which means I say n factorial is small o of n power n. Okay, this is small o. This is small o of n power n. So how to prove it? Like that can be proved using, there is something called stringless approximation, but we don't want to prove it. Okay, I mean, you need to put this n factorial as this, and then we can prove that n factorial is strictly lesser than ns power n. Can you little bit see that this n factorial is basically ns power n? This is nothing but ns power n divided by some very great function e power n, right? Ns power n divided by some great function e power n. So that's why it is strictly lesser. Okay, we can definitely prove it, but let's not do it now. Okay, I mean, you can take a log and you can try proving it, but let's not do it. So here what I'm saying, that n factorial is strictly lesser than n log n, strictly lesser than ns power n, which means that let's suppose this is your scale, and if this is n factorial, then too far. Okay, this is too far. If you want, I can just make it little more dramatic. See here, that this is, if this is n factorial, then this is ns power n. Actually both are too far. Okay, too far, which means this is actually strictly greater. It is asymptotically greater. Okay, this n factorial is asymptotically lesser than ns power n. But when you take the log, okay, interestingly, when you take the log, then both become asymptotically equal, which means log n factorial is equal to theta of n log n, which means both are exactly same. Okay, when you take the log, they become so close that they become equal. Okay, n log n. Okay, I should be writing C here, but I'm not writing. These are asymptotic equal. Okay. We can also prove this. That's a very easy proof, but currently I'm not doing it. Okay, we have done this in our class, in our full lectures, but I'm currently not doing. You can just try expanding this n factorial as n into n minus one, n minus one into n minus two, and so on. But the proof is not worth it, so we are not doing it currently. Okay. So I hope you understood this, that before taking the log, okay, before taking the log, in between n factorial and n power n, which one is what is the relation? Before taking the log, this is strictly greater. Interestingly, after taking the log, this is n factorial, this is log ns power n, or you can write n log n. Okay. After taking the log, both become equal. Okay. So before taking the log, this is the relation. This is, you need to remember this, that before taking the log, this is the relation. After taking the log, both are equal. Okay. So this is asymptotic. Obviously they are not exactly equal, but asymptotically they are equal, which means if you want, I can write the theta here. Okay, the theta here. Asymptotically they are equal. Obviously they are not equal, but asymptotically they are equal, right? Okay. Now let's just solve this question. This is MSQ question. What they are saying, which of the following is or are true? N factorial is basically strictly lesser than ns power n. What do you think? N factorial is strictly lesser than ns power n. Yes, that is true. N factorial is lesser than equal to n power n. If it is strictly lesser, then it is lesser than equal to also, right? That's why this is true. Which means, if I mean in general also, if let's suppose this is true, this definitely imply 5 less than equal to 10. Okay. So see, I'm not saying 5 equal to 10. I'm saying either 5 lesser or equal to 10. Okay. So basically, if A is less than B, then it definitely means A is lesser than equal to B. Okay. So which means if n factorial is strictly lesser, then it is lesser than equal to also. If you want, you can write lesser than equal to also, right? Okay. What about this log n factorial? Log n factorial is small o of no. They're actually exactly equal. So because there is a theta relation, it cannot be small o. Okay, it cannot be small o. So that's why this is false. What about this? This is interesting. See, if there is a theta relation, which means if they are exactly equal, then it means there, if theta is possible, then it means big O is there, big omega is also there. So if theta is there, then big O and big omega both are there. Okay, so D is the correct answer. So A, B, D are the correct answers here. Okay, A, B, D are the correct answers. Yes. Now let me just ask you one thing. Let's suppose I say n square equal to order of n square, or maybe I say 5n square equal to order of n square. Is this true? This is capital O. Okay, which means big O. Is this true? Yes, this is true, right? This is true. Now, can I also say that this particular relation also hold 10n square equal to order of n square? Yes, this also hold, right? Can I also say that 8n square is also equal to big O of n square? Yes, this also hold, right? This also hold. So all of this hold. So let's suppose this is equation number 1, this is equation number 2, this is equation number 3. Using all of this, can I say 5n square is equal to 10n square, and which means n square getting cancelled out, 5 equal to 10. Is this really true that 5 equal to 10? No, right? This is definitely not true. So what is we are missing here? So that's why we want to see the formal definition. So see here that we just used this equal sign, but actually it is belong. Okay, which means if I am saying 5n square or anything, okay, 5n square is equal to, let's suppose, or maybe I'm saying n square equal to order of n cube, or 5n square equal to order of n cube, or 10n square equal to order of n cube, right? If I'm saying something like this, okay, order of n cube, it doesn't mean I'm saying equal. Basically, just for our convenience we are saying it, okay, but it is not equal, it is belong, which means basically this particular thing is a set of functions. Okay, set of functions. This is a set. This is basically a set. This is just one function. This is just one function. Now, just for our sake of convenience, we are saying it. Otherwise, so we are saying it is a mathematical convenience, right? Just for our sake of convenience, we are saying this is equal. Otherwise, this is belong. Okay, that this belong this. Okay, which means ideally, what should happen, right? See, ideally, I should be writing that instead of writing this, okay, instead of writing order of NQ, instead of this, we should write n square belong order of NQ. We should write this, but this is also okay. I mean, this is also okay. Just for our convenience, we are writing it. Okay, our convenience. Is this okay to everyone? Okay, see here, this I have taken from Corman. Okay, I have taken this from Corman. They are saying this is a function. This is a function. Okay, this is a function. There exists some positive constant such that this, right? So this is a function. This is a function. This is a function. They are saying that it is a set of functions such that this is true. Okay, this order of Gn, it is a set of, it is just a set. This is a set basically. Okay, a set of functions. Okay, so we should ideally be writing belong, but we write equal. So this is for our sake of convenience. So here I was just saying that here I was just basically, you can say that using these three equations, I'm saying 5 equal to 10. No, I can't prove like this. So this is basically misusing. Okay, I mean, there's a term that called abusing the notation. So I'm assuming that abusing the notation is okay. But we should not misuse it, right? So you will see in your masters that there are sometimes that we abuse the notation, but we should not misuse it. So for example, see this, that this order of 1 means all of this, order of n means this, all of this, order of n log n means this, right? This is again from Corman. Okay, what they are saying, that for example we might extend the notation to real number. We should make sure, however, to understand the precise meaning of the notation, so that we abuse, we do not misuse. Okay, we should not misuse basically. Okay, we can abuse the notation, but we should not misuse them, right? This is from Corman. Okay, now again you see that here they are saying that sufficient, because this is a set, right? This is set. Okay, we could write this to indicate fn is a member of this. Instead we usually write this. Okay, we usually write this. Okay, we usually write this. We could have written this. We could have written this belong symbol, but we usually write this equal symbol. Okay. Let's just see this question. See here they have used this belong symbol. Okay, and some of the aspirants got confused that why this belong symbol is there. Now what they are saying, that f and g are the natural numbers given by this, right? Okay, so they are the natural numbers. So which means that there is no asymptotic or something. They're just some functions. Which of the following is or are true? Okay, you just tell me that it is very easy question. So fn is order of gn, right? Order of gn. So instead of equal, you can use belong symbol also. So this is the case, right? So which of the, see, this is multiple select, this is MSQ. So now you tell me the answer. Since this is MSQ, that's why A is answer, and this is less than equal to, so that's why C is also the answer. Okay, this is MSQ, right? Okay. Now can you tell me? Can you tell me this? This is a question I'm asking you. Okay, this is a question I'm asking you. You just try your best to answer this. Let such that fn is greater than gn. Okay, Fn is greater than Gn. Now can you tell me here, then can I say that or maybe let me write Fn is lesser than, strictly lesser than Gn. Okay, can I say that Fn is equal to small o of Gn? This is a question of true or false. Okay, just tell me this is true or false. Just tell me this. See, what I'm saying, let Fn and Gn be the two functions such that Fn is strictly lesser than Gn. Now, this is a question, right? Am I saying this is asymptotic? See, I can't say this is asymptotic or something. This is a normal lesser than, right? Which means Fn could be n, Gn could be 2n only. Normal lesser than. If it is normal lesser than, then can I say it is small a, small o? No, it could be even theta. So that's why this is false. Okay, this is false. So which means in the question they have given this is lesser, right? In the question they have given this is lesser. They are not saying this is asymptotic, and they can't say something like this. This is not a formal thing to say this is asymptotic. If they have to say this is asymptotic, they will be using the notation, right? They will be using the notation. See, whenever in the question, if they give you some function or something, if they use lesser than, greater than, equal, or anything, okay, or anything, it doesn't mean you can take it as asymptotic just because it is an asymptotic question. Okay, understood? Okay, so let me just ask you one more question. Suppose Fn equal to Gn, then this is also true false. Yeah, so then can we say that Fn is equal to theta of Gn? What do you think? Can we say Fn equal to theta of Gn? Yes, that is true. Why? That is true. What is the reason of that? This is true, right? This is true. What is the reason? Because both are same, both are exactly same. This is not theta or something. They are saying both are exactly same. Okay, if both are same, then both are n, or both are n square, or both are n cube, or whatever, right? If both are exactly same, then both are theta also. So that's why this is true. This is true. Okay. Now let me ask you one more. Suppose if they say that Fn equal to theta of Gn, then Fn equal to Gn. This is true or false? What do you think? If Fn is theta of Gn, are they really very same? No, this Fn could be n, this could be 2n, right? They are not same. They are not really exactly same. So that's why this is false. This is false, right? Okay. Now let me ask you one more. Let's suppose they say that Fn equal to, or maybe let's suppose they say Fn is equal to big O of Gn. Okay, this is big O. Okay, suppose they say Fn equal to big O of Gn, then can you say that Fn is strictly lesser than equal to Gn? Okay, let's suppose A, this is B, that Fn equal to greater than Gn. So which is true? Which is true? What do you think? Which is true? So again, see, they are saying they are related by big O, right? It means that asymptotically they are related. So it might be the case this is n. This might be the case this is n square, right? This is n square. So that's why this B is false. But this might be the case that this is n, Okay, or maybe this is 5n and this is n. So in general, you can't say in this you can't say this is less than equal to or greater than equal to, right? Because they are saying this is big O. So it means that this fn is less than equal to c into gn, right? It is c into gn. You directly can't compare like this. Okay, in general, the normal functions you can't compare. Okay, maybe this fn is little bit see greater by the constant. So by this information they are saying that it is really greater, or maybe it is greater by some constant. So which means that here if you put the c value as maybe 100, then 100n and 5n, which one is greater? This, right? 100n is greater. So it might be greater than by the constant, or maybe it is really greater, which means it might be n cube or something, right? Okay, so here you can't say anything. So neither this or this, right? Neither this, yes, neither this or this. Okay, none of this, none of a or b, none of a or b. Getting my point? See, what I'm trying to say, that this is the normal comparison. Okay, in the question if they are saying this is a normal comparison, it might be the case this fn might be like little bigger. Okay, in terms of the constant it might be little bigger, but if you multiply with the c, then it is bigger. That's why we are saying this is big O, right? So it may be the case this is 3n, then that's why this age false. If you're thinking about the a, then age false. Okay, so many of the people has commented as a, but this age false. This is a normal function. Okay, in the question formally I can't say this is asymptotic comparison or something. Okay, formally I can't say. See in all of this, right? In all of this, whenever I'm writing, let's suppose, see, whenever I'm writing something like this, let's suppose I'm saying all comparisons are asymptotic. So ideally I should be writing, see, ideally I should be writing I'm just to not make you much confused. Ideally I should be writing like this. Okay, this is a small omega of gn. Okay, which means it is strictly greater. I should be ideally writing a small omega or something. Okay, I can't say it is greater and then all comparisons are asymptotic. This is not a very formal thing. Okay, this is not a very formal thing. So if they say something like this, then it is just general comparison only. Okay, but instead of I actually meant this is asymptotic comparison. Okay, so instead of writing like this, I'm writing like this just for our sake of understanding. But in the question, if they're using this greater than symbol, it doesn't mean they are saying asymptotic. Okay, are you understanding? It doesn't mean they are saying asymptotic. In the question, if they are using this greater or lesser, okay, here I'm explicitly saying they are asymptotic. So that's why I'm saying n square and 5n square both are equal. Are they really equal? No, this is theta, right? This is theta. They are not really equal, but I will say, okay, asymptotically equal. Okay, just for our sake of saying, I'm saying it. Understood? Okay, so in the question, if they are using, see here in the question, if they are using lesser than symbol or something like this, it doesn't mean it is asymptotic comparison. They are really asking whether these two functions are really lesser or greater. Then you can't comment, right? You can't comment. Is this okay to everyone? Let me know. Okay. Now let's see this question. This question I have taken from MIT. Okay. Just tell me which is true. If theta is the relation between fn and gn, and here also theta, can you say this is theta? Yes, right? If these two are equal, then obviously these two are equal. What about this? If this is basically less than equal to, this is again less than equal to, can you say hn is greater? So basically fn is less than equal to gn is lesser than equal to hn. Okay, so this is just asymptotic comparison. Then can I say hn is greater than equal to fn? Yeah, so fn is less than equal to hn, which definitely mean that hn is greater than equal to fn, right? So B is the correct answer here. Okay, so okay, let's just check other options also. So yeah, A and B are the correct. Now what about C? If fn is order of gn and gn is order of fn, which means again they are saying this is lesser than equal to, then this is also lesser than equal to, then they are okay. Yeah, this is interesting. Can you tell me this? See, they are saying that this function fn is lesser than equal to gn, Okay, I mean c into, I'm not writing c. Here they are saying this gn is also lesser than equal to fn. Okay, this should be some other c. Okay, are they really equal or this is just theta? Tell me. This is a theta relation, right? This is a theta relation. So if they say this is currently, this is false, maybe you can take the example, maybe it is 3n, this is n, right? It is true, right? This is n, this is 3n. These two are true, but 3n and n are not equal, but they are theta. So they are actually theta. They are not really equal. They are theta. Okay. What about this? This constant you can definitely ignore. Yeah, this relation is theta. So if this is theta, then big O and big omega both are possible. So D is also correct answer. So I think A, B, D are the correct answer. So this is true, this is false, this is true, right? So A, B, and D. Right? This is false. Okay, understood? Now let's just go to the next question. So tell me, if Fn is order of n square, then Fn is also order of n, which means if Fn is lesser than equal to n square, okay, I mean, I'm not writing C, okay, see, I'm not writing C, don't get confused. So here, this should be C actually. But yeah, if Fn is less than equal to n square, then does this mean it is also less than equal to n? What do you think? What do you think? No, right? No. So that's why this is false. This is false. Okay. Okay, let's just see this. What they're saying, if Fn is strictly lesser than Gn, okay, I should be writing C, and for every C I should be writing the formal definition, but let's not worry about it. Then it is always the case that Fn is lesser than equal to Gn. If it is strictly lesser, then can you say it is also lesser than equal to? Yeah. If 5 is strictly lesser than 10, then you can also say 5 is less than equal to 10. I mean, if it is strictly lesser, then you can definitely say. So that's why this is true. If it is lesser than equal to, then can you say it is strictly lesser? Can you say it is strictly lesser? No, right? So that's why this is false. If it is lesser than equal to, then maybe both are really equal. This is n, this is n, right? It is strictly lesser? No. So that's why this is false. So A is true and this is false. Okay. Yeah. Now let's just move to little more interesting questions where I will talk about the exponent and log, which means I will talk about that if Fn and Gn are related by something, okay, maybe this is order, then what about Fn and what about this 2 power Fn and 2 power Gn, right? What about log Fn and log Gn? So basically, let's just talk about these kind of questions, right? These kind of questions where most of the aspirants get confused. That if Fn and Gn are related, then if we put them in the power, then what is the relation now? See, this is the current relation, right? Less than equal to. Is this relation currently still hold? Okay. Is this relation still hold? Let's just see this. Okay. So let's just see very first question here, where they are saying assume that two functions f and g are such that fn is less than equal to gn. I'm not writing c. Okay, just pardon me here. I'm not writing c, but it should be ideally c. Cool. If fn is less than equal to gn, then what you can talk about, what you can say about this 2 power fn? Okay, what you can say about this 2 power fn and 2 power gn? What do you think? See, whenever the things goes in the power, right? Then you should be little careful, right? Let's just see why. So see, if this is the relation, then can you say that if you take the 2 power, then also asymptotically this is the relation? What do you think? Just think about it. Just think about it and let me know what you are thinking here. So if before exponent both are related like this, then after exponent they are related like this, or the relation will change, or you can't say anything or something like this, right? Just let me know. See here it might be the case. Try to take some case where asymptotically this is the case, but in reality this is greater. So let's just take something. Let's suppose this is 2n, this is n. Okay, in reality this is greater, right? Now if you take the power, okay, if you take the power, which means if you take 2 power 2n, and here 2 power n, which one is greater? See, the constant is playing a role here, right? I mean, if you take the power, then you can divide by 2 power n, it will be 2 power n, it will be 1. So obviously this is greater, right? See, before that you can say, yeah, this is less than equal to, or maybe this is relatively big O. But after 2 power, you can't say, because the constant is playing a role, right? A constant is playing a role. So are you understanding this? That if fn is big O of gn, right? Then what about the powers? See, they are asking what about this 2 power fn, and can you compare 2 power gn? Let's just check. See here, this fn you can take maybe you can take some function. Maybe let's just take it as n. Okay, let's just take this gn as 2 power n, or maybe 2n only. Okay, then now tell me, is this still hold? Yeah, then it is holding, right? Then this will be 2 power n, and this is 2 power 2n. Then yeah, this holds, right? Or you can divide by 2 power n, then you can definitely check it will be 2 power n only, right? 2 power n only. So then this holds. But suppose you reverse the role, right? You can definitely reverse the role. So here it holds, but let's suppose you reverse the role, which means this is not 2n, this is now 2n. Then this will be like this, right? This will be like this. Then does this hold? No, it doesn't hold. So basically sometimes as you can see, so here, sometimes if that is the case, this is lesser than equal to, right? I mean, this is lesser than equal to, this is the relation that holds, right? Sometimes this is greater than equal to, this is the relation that holds. If you take fn and gn, something like this. If you take both as equal, which means if you take both as n, then it will be actually equal, right? Then you can say it is even related by theta. Okay, sometimes it will depend on the exact value of fn and gn, right? So sometimes as you can see, it is lesser than equal to, right? Sometimes it is lesser than equal to, sometimes it is greater than equal to, sometimes it is exactly equal, right? It is exactly equal. So basically it depends. I mean, it is theta. Basically it depends on the real values of fn and gn. So that's why you can't say anything, right? So if fn and gn related like this, see, this is one very important and one very less understood topic. See, what we are currently discussing is that if fn and gn are related something like this, then what about 2 power of them? What about log of them? Okay, this is what we want to discuss. This is very less understood to almost every aspirants. Okay, very less understood topic. And most of the coachings doesn't teach this. But let's just see the examples from the standard resources. Okay, we are going to see the examples from the standard sources. Cool. So here you can't say anything, right? Okay, so however we saw the last week. So basically, that's what they are saying, that this is, let's suppose fn, this is gn. Okay, currently they are related by order, but now they are not related by order. Okay, let's see this question. Now they are saying that if, let's suppose this is the case where fn is order of gn only, but what about the log? After taking log, what do you think? Which means now I'm saying fn is actually lesser than equal to c into gn, or maybe, okay, I'm just writing it simply, gn. Let's suppose I'm saying something like this. Then what about after log? If it is lesser than equal to gn, okay, what about after log? What do you think? See, after the log, it can't be greater, okay? Which means if fn and gn are related like this, see here, are related by order, right? Order. Then what does this mean? You can take anything. You can take this as 2n or anything. Actually, the thing here is that if this 2 goes in the exponent, then it creates a problem, but it goes in the log, okay? It is still a constant actually. Okay, if it goes in the log, it is still a constant. So that's why this 2 won't matter here. Okay, that's why this 2 is not a bother here. See, earlier this 2 was bothering. Why? Because this 2 was not in log, it was in the exponent. I was saying 2 power 2n. Here 2 power n. It was in the power. If it is in the power, then it can create a problem. But if it is in the log, it won't create a problem. So if if earlier both are the big O, then after log also, at most, see, if earlier I am saying two functions are like this, see, if earlier I am saying two functions are too far, maybe, okay, or maybe they are related by big O, then after taking log, what will happen? Tell me. See, suppose I write it here. Okay. So after taking the log, it might be the case that both are too close. It might be the log of fn. Okay. And they become too close. But it won't be the case that after taking the log, it can't cross each other. Okay. They can't cross each other asymptotically, at least, right? So which means this 2, if this 2 is in this function, that won't create a problem here. So that's why this is true. Okay. So see, if fn is big O of gn, then if I just ask you that what about if I send them in 2 power, is this true? 2 power fn is also big O of gn. Is this true? What about I send them in log? Is this true? Log of fn is equal to order of log of gn. What about this? Just tell me. Is this true? Is this true? What do you think? What do you think? So see here, this is false. We have seen, right? Because if there is some constant here, that can create a lot of problem, right? But it won't create a problem here. So this is true. Okay, this is true. Understood? Cool. Now let's just see more questions. Let's just see this. Consider the case where fn is equal to order of gn. Now tell me this s1 and s2, which one is true? Can you comment anything about their relation? Can you comment anything if they're in 2 power? Can you comment anything? We have seen multiple cases, right? We have seen multiple cases where sometimes it is actually, see here, sometimes it is greater or lesser or whatever you want to say. This is greater, right? Sometimes equal. So basically we can't comment, right? We can't comment. So what is the answer here? Can anyone tell me? This question is from our test series question. Can you tell me what is the answer? This is a data structure test. Okay, data structure test question. So both are incorrect. We can't say anything, right? Both are incorrect. Hope you understood. Okay. So solution is B, basically. B means both are incorrect. Now let's just answer this. This question is from the weekly quiz. Okay. This question is from the weekly quiz, from our Go classes weekly quiz. Okay. You might have solved it, but since it is a revision, so let's just solve this again. Consider this function f and g, both are positive and increasing functions. Which of the following is correct? Okay. If both are related by small o, then their log is also related by small o. Is this true or false? See, earlier if they are related like this, then their log is also related by small o. Which means earlier if I am saying, in fact we have seen some counter example here, right? Already we have seen. See, we are saying earlier if fn and gn are too far, okay, I mean this is strictly greater. I should be writing c and all, but I'm currently not writing. Okay. And earlier if that is the relation, then after log also this is strictly lesser. We have in fact seen one classic counter example. Can you tell me some classic counter example we have seen? In this lecture only we have seen one very classic counter example, which is of n factorial and n power n. Let's just take n factorial and n power n. This is before taking log, it is strictly greater n power n. But after taking log, it is actually equal. Equal means theta, right? This n factorial after taking the log is same as n power n. Okay, same means it is theta basically. I should be writing theta. Okay, cool. Understood? Let me know. See, if before taking the log they are strictly lesser, then after taking the log maybe they are equal, right? It can't be the case that this cannot be greater after taking the log, but it can be at least equal. Which means if two things are far apart, okay, before taking the log, if two things are far apart, right, far apart, then after taking the log they may become close, but it can't cross. Okay, they may become asymptotically equal. So that's why you can say that this particular is false. What about if they are related like this? Okay, let me just take this particular on the next page. if they're related like this, which means they are saying earlier they are related like this, less than equal to gn. Now can you take some e power or 2 power, whatever you want to take, e power fn? Can you comment anything about this? Can you comment anything? No, right? We have seen the examples also. Like if that is the case, then later on maybe greater, maybe lesser, maybe equal, so we can't comment anything. That's why this is also false. What about this? Okay, after log, see, they are saying this C is also the similar option we have seen, right? The similar option we have seen. So they are saying here the C option is basically saying that this fn is less than equal to gn. Then after taking the log, what do you think? After taking the log, actually, if this is the case, then log cannot reverse this, right? Like log can never reverse this. So basically after taking the log also, they might become equal. I'm not saying that this will be lesser than only. They might become equal, they might be lesser than only. Okay, after taking the log anything can happen, but it can't reverse the role. So basically that's why this is true. Okay, so let me just zoom this a little bit. Okay. Now let's just go to the option D. Okay, let's just go to option D. See, here this C is true. Now let me just zoom and let me just go to the option D. Now what this option D is saying, let's just see if you can answer this question. What this option D is saying? They are saying Fn and Gn are related like this, that Fn is strictly lesser than Gn. Okay, I should be in fact writing theta. Oh, sorry, C. I should be in fact writing C, but I'm not currently writing anyway. So now they are saying that if they're strictly lesser, okay, which means Gn is actually strictly greater. Gn is strictly greater. Then after power, let's take 2 power or any other power, e power or anything. Then what do you think? What do you think after the power? If earlier that is the relation, okay. See here the constant can't play some role. See, earlier if this is strictly greater, so it has to be, let's suppose, n square, then it can't be just 2n square or something, right? It has to be function lesser, right? Let's suppose this is n. Then what do you think? Let me just I want you to answer this question. So what do you think, what will happen now? So this is true, right? This is true because earlier the constants were playing some role. So if this is lesser than equal to, then I tricked it using the constant. But if this is the case, then which is strictly lesser, then I will say that okay, even after the power, it is strictly lesser only. Okay. So let me just see the answer here. D is the correct answer. So what are the answers? C and D are the answers, right? C and D are the answers. See here, C and D are the answers, right? Okay, C and D are the answers. Okay, so let's just see some conclusion. Let's just see some conclusion. See here that if I just say, okay, if I just say Fn is equal to order of Gn. Now here this order is big O. Okay, this is big O. Now, what does this mean? What does this mean? This basically mean that if I just ask you 2 power Fn and 2 power Gn, then what do you think? If I just ask you log Fn and log Gn, then what do you think? So just tell me what should be the conclusion here if this is big O. Okay, for the big O, what is the conclusion that we have? What do you think? Here we can't comment, right? We cannot comment. Here this will still hold. If it is less than or equal to, this will still hold. So order of Gn, this is big O only. Big O. Okay. Okay, understood? Now let's just see this. Let's suppose if I just ask you this. Okay, suppose this is small o. Okay, suppose instead of big O, this is small o. So let me just copy on the next page and let me just ask you. Suppose this is not a big O, this is a small o. Then what do you think? What is the answer? If this is a small o. See, we have seen this, right? In case of a small o, actually this is true. Okay, this is again a small o. This is again a small o because I can't trick with the constant. See, we have seen if it is a small o, then in power also it is okay. Okay, but in log we have seen the counter example here. Can you give me the counter example here? In the log we have a classic counter example. Right, so what is that? Like we cannot basically say anything. It may be at most equal. Obviously it can't reverse, log can't reverse the role, but it may be equal, right? Maybe theta, or maybe it is let's suppose like this, maybe small only. It can't reverse the role, right? It can't reverse the role. So basically let me just conclude you one more time, because this is very very confusing to many of the aspirants. So that's why I'm taking a little bit of time here. So let me just quickly conclude it. So fn equal to, let's suppose, big O of gn. Okay, so here now there are two things, and maybe fn equal to small o of gn. Okay, let's suppose it is small o of gn, and then we will solve many other questions related to this. But before that, let me just conclude it. Okay, here in case of big O, if I just ask you what about the relation between this. Okay, let me just copy this so that I do not need to write it again. Okay, so suppose here if I just ask you what about the relation between this, then what is your answer? Just tell me. See, here we can't comment, right? We can't comment because the constant can play some role. We can't comment. Maybe equal, maybe greater, or anything, right? Maybe equal, maybe greater, maybe lesser, right? We can't comment because the constant is playing too much of role. See, just because of the constant it is 2n, this is n. Just because of the constant it is strictly greater. Just because of the constant, let's suppose you can definitely take it as a n and this is a 2n, right? Just because of the constant it is strictly lesser. Just because of the constant, let's suppose you take both of as n, it is equal, right? So that's why it can be strictly lesser, strictly greater, equal, right? But what about log? Log can't reverse it. If this is earlier it was lesser than equal to, then also it is lesser than equal to. Log can't reverse the role. Okay, this is big O only. Log can't reverse the role. So what about this? What about this? If this is small o, see, what about log? Since log can't reverse the role, that is why can you first tell me what about the log? Now for the log you will say, see, for the log, let me just write for the log first. For the log, what you will say? If this is strictly lesser, then it can't reverse the loss. So maybe it is lesser or maybe equal. So this is big O, right? This is big O. This is big O. Okay. 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 Great. So this is big O. What about this? Now, if Fn is strictly lesser, then if you're taking the power, now constants can't play the role here. Okay, so that's why, see, in the log, just check that, okay, it can't reverse the log. In the experiment, just think about the constant. Since the constant is not a factor here, because gn is strictly greater, so that's why it is again strictly greater only. Okay, so I can say that whenever you are thinking about the log, just think about one thing, that constants can't play any role. Okay. Sorry. When thinking about the log, then you say that okay, log cannot reverse the role, right? Reverse the role. Thinking about exponent, then see if constant can play some role. Okay, understood? Cool. So that is all about this particular comparison. Now let me just ask you. Let me just ask you. Let me just see if you remember that or not. Let's suppose there is a function fn, there is a function gn. Okay. Let's suppose they are related by small o. Okay. Then can I say let's suppose this is a, this is b, this is c, this is d. Okay. Can I say log of fn is also equal to small o of log of gn? Can I say this? Log of fn is equal to big O, okay, big O of log of gn. Log of fn equal to theta of log of gn. Log of fn equal to maybe you can say omega of log of gn. Which one is true? See, if earlier before taking the log, if this is strictly lesser, then after taking the log it may be equal, or maybe lesser, right? So can you say it is always strictly lesser? No, maybe equal also. So that's why this is false. Maybe lesser than equal to, so that's why this is true, right? That's why this is true. Will it be always be equal? Can you guarantee that this will be equal? No, right? You can't guarantee that this is equal, right? You can't guarantee this is equal. So that's why this is false. Neither it is greater. So that's why only B is the correct answer, right? Understood? So let's now solve some questions. Okay. Let's now solve some questions. Don't worry. You will get to understand this. So here I am saying that if they're related by big O or maybe small o, then if they're related by big O, then after after the exponent that constant may trick you, but here the constant can't trick you. Here one thing is for sure, that if they are strictly lesser, then after log they may be equal. So that's why big O only. Okay. Here after the log you don't know. Okay, you don't know that what may so happen, right? Because sorry, here after the log, if this is big O, then this is, if this is lesser than equal to, then since log can't reverse the role, so that's why this is also lesser than equal to. But here you don't know because the constant can play some role. Okay, now let's solve this question. This question I have taken again from the weekly quiz. Okay, this is again from Go Classes weekly quiz 23. This was a MSQ question. Okay, this is MSQ question of 2 marks. Okay, if you are Go Classes student, then you might have solved this. But let's not worry about it. Let's just solve this now. So they are having positive functions f and g, and fn is they have given that fn is big O of gn. Okay, then which is true? Okay, then which is true? Fn is given as big O of gn. So here this is given. See, if you take the 2 power, then it may trick you, right? So constant may trick you. So that's why no. Okay, this is interesting. We will see this. Now gn is theta of itself, right? So if theta is possible, then this is possible, right? Okay. Now fn square, here instead of taking the exponent or log, they are taking the square. Okay, they are taking some other function which is a square function. Now they are saying that fn is lesser than equal to c into gn, or maybe let me just write gn, then can you say the square is also there? Fn square, you take the square both side, is also lesser than equal to gn. What do you think? Just think about it. It is a good question. Let me know. See, let's just see if the constant can trick you. Okay, let's just see if the constant can trick you. In this case, the constant is only thing that can trick you. If you are doing some power exponent, let's just see. Let's see. This is 2n. Let's see. This is n. Okay, let's say this is n. This is 2n. Is this true? If this is 2n, this is n. Is this relation true? Yes, right? So if that is confusing you, let me just remove this. See, this relation is definitely true, that if this is 2n and n. Now let's just see. Let's just see what is happening now. Now, if you take the power, okay, if you take the power, then this will be 4n square, and this is n square. Then also this constant will be just constant, right? I mean, this constant will be, you can definitely ignore this constant, right? I mean, it is not going in the exponent. The thing here is that this constant is not going in the exponent. If the constant is going in the exponent, that then only it can trick you. Otherwise, it is again a constant, right? It is again a constant here. Whatever is the relation, it is again a constant. So it is not able to trick you, right? Even if you take this as n, this is, let's suppose, 2n, it won't matter. Ultimately, this is also the constant later on, right? Later on also this is a constant. This is 4n square, this will be just n square. So you don't need to take the complex function n cube plus 5 or something, right? You can just take n, okay, and just see if the constant can trick you. See, in the exponent, constant were able to trick you, but here the constant is not able to trick you. So that's why B is the correct answer. What about the C? What about the C? Fn, if fn is some function which is positive, and let's suppose I think they've given that two positive functions. Okay, now can you tell me, positive means that the value is always greater than 0. Can you tell me fn is always lesser than equal to fn square? What do you think? Is this always true? Let's suppose fn is 1 upon n. Is this lesser than equal to, I mean, this 1 upon n square is greater? Do you think? Do you think this 1 upon, see, just tell me in between 1 and 1 upon n, which one is greater? Which one is greater? Let's suppose this is fn, this is gn. Which one is greater? So I can definitely say that fn is, or maybe let me write in terms of gn. Gn is strictly lesser than fn. Okay, strictly lesser than fn. You can multiply by the n, right? You can multiply by the n, and then you can see. Okay, you can definitely multiply by the n, and then you can see. Multiply by the n, it will be 1. It is strictly greater. So fn is strictly greater, which means gn is small o of fn, right? Is small o of fn. Okay. If there is any decreasing function, so if this is decreasing function, then even constants are greater, right? Constant is greater than that. Okay. If they ask you to compare between 1 upon n and 1 upon n square, then what is the answer? You multiply by the n square, it will be n, it will be 1. Obviously, n is greater, right? So this is greater. So after taking the square, it might not be the case that this is greater, right? It might not be the case. So that's why this is false. This is false. Because this fn I have taken the decreasing function, right? So B and D are the correct answers here. Okay, this is, I know this is very tricky question, but don't worry, we will solve more question, then you will get to understand more. Let's just see this question which I have taken from Northwestern University. Let's just see this question. If fn is okay, the question number might not be the correct. Okay, so if fn is theta of gn, then fn equal to gn, fn power gn equal to theta of gn power fn. So just think about it and just try solving it. So they are saying if both are related by theta, right? If both are related by theta, then what can you say? What can you say about these functions now? See if the constant can play some role. So fn, let's just take it 2n here. Let's just take it n, right? So it will be 2n power n, and it is n power 2n. So this is definitely 2 power n into n power n, right? This is n power n. You can divide by the n power n both side probably, right? You can divide by the n power n both side, and this is n power 2n. If you divide by the n power n, it will be 2 power n. It is n power n, right? So which one is greater? You can take the log, it will be log n log 2, so maybe n, and it is n log n. So n power n is greater. So basically this is greater, right? This is strictly greater. But you can definitely reverse this, right? And then you can make other greater. So that's why you can't say this is theta. You can't say this is theta, right? So what is the answer here? This claim is false. Okay, just see if the constants can play some role. If this is exponent or something, just see the constants can play some role. And then you can definitely take it, this as 2n, this as n, you can definitely reverse the role, right? Let's suppose this is big O or small o or something. Then also this is false. You can't comment, right? Whether this or any relation, you can't comment between these two functions. Sometimes this might be greater, sometimes this might be greater, sometimes this might be greater, sometimes both may be equal, right? If both are n, then both may be equal. Just see if the constants can trick you in, if they are talking about the exponent, okay? Then the constant will trick you. Definitely it will trick you. Let's see this question. So what they're saying, given this, so let's just see this, what they're saying. Given these two functions, f is basically strictly, not strictly, sorry, f is greater than or equal to log n, and g is lesser than or equal to n. Ideally, I should be writing C1, C2 or something, but I'm not writing, okay? This is the asymptotic way. I'm just writing in the asymptotic comparison. Consider the following statement. For each of the statement, write whether this is true or false. For each of the statement, write two functions f and g and show the counterexample. Okay. So let's just see this. So if f is strictly greater than, f is greater than or equal to log n, and this is less than or equal to n, then what do you think about this? The gn, maybe let me just write g, is lesser than or equal to f. See, this is something which can be log n also. This is something which can be n also. Can you say? Can you say something like this? So what do you think? No, right? So that's why this is false. So, okay. So this is false. And what is the counterexample? Here, so one is false. You can definitely have g as n and f as log n itself. Okay. What about this? Can you say f is less than or equal to g? No, right? F can be n square also, because it is greater than log n. So it can be n square. G can be n, right? So again false. What about this? Can you say that f is greater than equal to log of gn? Tell me. See, if f is greater than equal to log n, okay, and g is less than equal to n, then can you say f is greater than equal to log of gn? Basically, ideally, I should be writing like this, that given that f is big omega of log n, g is big O of n, then can you say f is big omega of log of gn? So what do you think? Can f be greater than or equal to log of fn, log of gn? See, gn, maximum value of gn could be n, right? Even if it is n, then also this is log n only, right? Now, and f is anyway greater than or equal to log n, right? F is anyway greater than or equal to log n. So you will be taking the minimum value of f. Even if you take the minimum value, then also it is okay. So basically this is true, right? This is true. Understood? Okay. Now they are saying they're related by theta. Can you say they're related by theta? This is, I mean, if you put the theta here, are they equal? No, right? What about f? F can be even bigger function, n cube, right? F can be even bigger function. If it is f is n cube, then they are not equal. Okay. If f is n cube, then they are not equal. So this is false. What about this? F plus g equal to big omega, which means they are greater than or equal to log n. Yeah, if f itself is greater than or equal to log n, then definitely, right, you can add anything here, it will be greater than or equal to log n only, right? So that's why this is also true. So 3 and 5 are the true answers, which means 3 and 5 are the true. And the counter examples I have written here, you can see. Okay. Let's see this MSQ question. Suppose that age this, b is this, then what about, let's suppose that k is greater than or equal to 1. You can take any value of k, and you can take any value of epsilon, where just epsilon has to be just greater than 0, right? See here, let me just zoom it little bit. Okay, tell me that in this case what will happen. See here this n power, this b is actually strictly greater than a, right? So this b is, because n power anything is strictly greater than log n power anything, so that's why this is true, right? B is less than or equal to strictly greater than, also true. A is greater than or equal to no, A is strictly greater no. So A and B are the correct answers, right? A and B are the correct answers here. How to prove this? You can definitely prove this using log. See, log n power k and n is power epsilon. So which one is greater? You take the log, it will be k log of log n, right? K log of log n, and it will be epsilon log n. These are the constants, let's not worry about it. Between log n and log n, definitely log n is greater. You can put log n as k, it is log k, right? It is strictly greater. So even after taking log, it is strictly greater, right? Even after taking log, it is strictly greater. So which means originally it must be strictly greater, right? It is greater. Okay. Yes, great. Now let's just see this question, which I have taken from our weekly quiz 23. Okay, let's just see this question. This is big omega, and this is big O, right? Now what they are saying is that, let's suppose Gn is something like this, Hn is something like this, then Hn into Gn. Okay, what it will be. So what does this say? This says that Gn, is this visible or should I just zoom it little more? Let me know. See, this particular term says that Gn is greater than or equal to n, right? I mean, I should be writing C, but I'm not writing C. Okay, this particular term says Hn is less than or equal to n. Okay, I should be writing C here also, but I'm not currently writing. Anyway, so this is what this says. This is what this says. Now they are asking that what about this product? See, this Gn is always greater than n. If it is always greater than n, maybe n or n anything, then if you multiply by the something, let's suppose you're multiplying by the log n, then obviously greater. If you multiply by, let's suppose, just constant, then obviously greater, right? Or equal, maybe equal to n. So basically, if you multiply by the log n here, then obviously greater than n. If you multiply by the constant, even if you multiply with the constant, then also it is equal to n. But the problem will occur if the Hn is, since Hn is less than or equal to n, they have not said it is increasing function or anything, right? Problem may occur if Hn you take till constant is fine. If it is take 1 by n, right? Then what will happen? If you take it as a 1 by n, then it is just 1, right? It is just 1. So it depends on Hn, right? It can degrade this Gn or to maybe anything, right? So it depends on Hn. So basically, it is definitely not theta, definitely not big O, because it depends on the Hn. If the Hn itself, let's suppose this is big O, right? So which means you can't say that it is lesser than equal to or greater than equal to. See, n into something, okay? Something, I can take anything here. If you take n into anything which is basically lesser than equal to n, okay? At most, if you take n, then it is n square. If you take n into, let's suppose they have not since they have not given that this should be increasing function, it could be 1 also. So it can be 1, it can be n square, it can be even decreasing function, which means if this Hn is too bad, maybe let's suppose 1 upon n cube or n square or n cube or anything, It could be 1 upon n square, right? So it depends that what is the value of h, what is the value of g. So you can't say anything, right? It may be good function, maybe just constant function, maybe the decreasing function. You can't say. So that's why none of this. Understood? None of these. Okay. I hope you understood. Now let's just see more question. So see here, D is the answer. See here, for those who have marked ABC thinking that this is MSQ. Okay, so I think I have given that as an MSQ. Okay, multiple select. Yeah, this was a multiple select I have given as an MSQ I have given. And then those who are thinking that okay, this is MSQ and then I should be marking ABC. Okay, then the question is saying, see, the question is saying, what will be the value of Gn into Hn? What will be the value? So if you are saying this will be the value, this will be the value, this will be the value, this will be the value. In fact, you are saying all of them will be the value, right? Which means you are saying theta. See, the answer is saying, understand the question language. It says will be. If you are saying ABC, then it means you are saying ABC together. This means theta of n, which is wrong, right? Okay. So D is the correct answer. You can't comment. What will be the value? You can't comment. Okay, Hn can possibly be 1 by n. Hn can be just n or anything. It depends, right? Now let's just take this question. This question is again from our test series question, I think. Yeah, this question is from our test series question. Let's just see this. Okay, this is test series data structures test number 2. Okay, let's just see what they're saying. Okay, and let's see if you can solve this question. So I hope this question is visible. Now what they're trying to say, that if both are related by small o, okay, if both are related by small o, then there is some increasing function, positive increasing functions, right? So there is some increasing function, maybe it could be log, maybe it could be exponent. Okay, then also they are related by small o. See, log is also increasing function, exponent is also increasing function. Now they are saying that if they are related by small o, okay, then after some increasing function, now they have not specified the increasing function. It could be log, it could be exponent. Now they are saying then also this is they are related by exponent. They are related like this. See, they are saying this fn is strictly lesser than gn. Now we have seen the example that if this h function is basically log, right? Log. We have seen the example that after taking the log, they are actually equal. This is not strictly lesser. So that's why this is false, right? The classic example, right? The classic example. So if h is log, then we have seen the classic example of n factorial and n power n. Earlier they were strictly lesser, but now this is equal. I mean, theta I should be writing. Okay, this is theta of n log n. Right? So that's why this is false, right? What about this? Now they are saying, now they have not given actually whether it is exponent function, whether it is a log function, but they are saying if fn is lesser than or equal to gn, then you take some function which is some increasing function h. Okay, you apply some increasing function both sides, then what can you say? See, we have seen that if this is exponent, then it played a role, right? In case of exponent, we can't say anything. If this h is exponent, then from here, this 2 power fn, we have seen that 2 power fn, 2 power gn, we can't say anything. If fn is, let's suppose n, this is 2n, the story is different. If this is 2n, this is n, the story will be different. So we can't say anything, right? If this is exponent, then we can't say anything. So what is the answer? What is the answer? It depends, like, I mean, if h is exponent, log, or what kind of function it is, right? So that's why neither s1 is true nor s2 is true, isn't it? So that's a really good question. Here the answer is both statements are false. Let me know if you have understood this particular question also. Okay, see, it depends, right? So here that's why D is the correct answer. Okay, both statements are false. D is the correct answer, right? It depends that what kind of function we are using, and we have seen multiple examples now. Now let's just see this question which I have taken from Stanford. So the thing here is that we have covered all the variations that are possible with respect to fn and gn are related like this or something like this, and then what happens when we take log or when we not take log or something. We have covered many other variations, right? Now let's just see some more questions. Okay, let's just see some more questions. So this question I have taken from Stanford. What they are saying, that if Tn is n power c, okay, maybe let's just take Tn is n cube. Then what about 2 power n cube? 2 power n cube. This is 2 power n. Okay, this is lesser than equal to 2 power n. No, definitely no. It is greater than equal to 2 power n. What do you think? So you take something which is ns power 0. Okay, so basically it is they are asking about 2 power ns power c and relation between 2 power n. What do you think? 2 power ns power c and 2 power n. Obviously this is greater, right? If c is greater than 1, then this will be greater. You can take the log and then you can see, right? You take the log, it will be n power c, it will be just n. If c is greater than 1, then obviously this is strictly greater. So this is strictly greater. So that's why this is a MSQ question. That's why B is the definitely correct answer here, right? B is definitely correct. What about C? They are asking that this function is 2 power ns power c. Okay, they're asking the 2 power ns power c versus 2 power 2 into tn is ns power c. So this is nothing but, if you want, you can basically divide by 2 power ns power c. I mean both side. This will be 1 and this will be 2 power ns power c. So this is strictly greater, right? This is strictly greater. Theta no. Okay, this is strictly greater. What about this? They're asking 2 power ns power c and 2 power 100 nc. Are they theta? Sorry, are they is this the relation true? So maybe you can take the log, it will be ns power c, it will be 100 nc. So ns power c is definitely greater than, because the c is a constant, so ns power c is definitely greater. So that's why D is the correct answer here, right? D is the correct answer. So B and D are the correct answers here. Okay, B and D. Understood? Let me know. Okay. Now let's just see this. So n belongs to this. Is this true or false? What does this mean? It means that n is strictly this is the small. Can you tell me what symbol this is? See, in the small we have small o and small omega, right? Small omega. So which means n is strictly greater than 2 power square root of log n. Is this true? Take the log, it will be log n, it will be square root of log n. So you divide by square root of log n, it will be square root of log n, it will be 1, right? Is this true? What do you think? Is this strictly greater? So even after taking the log, this is greater, right? Even after taking the log, this is greater. So that's why this is true. So before taking the log, also it is definitely greater. So even after taking the log, this is greater. So before taking the log, this is definitely greater. Okay. So we have seen this, that after taking the log, if we know that this is greater, then before taking the log, that definitely greater. After taking the log, if the equal coming, then we don't know, right? After taking the log, if equal is coming, then we don't know. Let's just see this. This is empty set. What do you think? So here they are saying this is the set of all functions which is this is interesting. See, let's suppose this is fn. Okay, fn equal to small o of gn. Then it means that it is lesser than, right? fn is strictly lesser than gn. So this is set of all functions which is greater than gn or lesser than gn. Interesting. This is set of all functions which are fn, right? So see, if this is fn, this will be some function which is just type of fn, right? Which is strictly lesser than gn. So lesser than gn, strictly lesser function than gn, right? Lesser gn. This is similarly, this will be greater than gn. So what do you think? So that's why obviously strictly lesser than gn, strictly greater than gn. So that's why this is empty set. This is true, right? This is true. Okay. Now let's solve this. Okay, maybe this is easy question. The answer is on the next page. You can just try solving this. Okay, you can just try solving this. Maybe we can solve this D. They are saying that set of either. So they are saying that two functions are always either this or this. Okay, let's just answer only this D. Tn and Gn are two functions are always like this or this, which means Tn is always lesser than or greater. What do you think? They may be incomparable also, right? They may be incomparable. We have seen multiple examples of incomparable. They have given you one example here. Okay, they may be incomparable also. Yeah, this question is interesting, which is from MIT. Can you just answer this question? Just let me know what is the answer. They are saying that Fn plus small o of Fn, okay, is equal to theta of Fn. This is true or false? See, this small o of Fn means what? Function greater than Fn or lesser than Fn? See, if there is any function which is small o of Fn, it means the function is strictly lesser than Fn, right? This is strictly lesser than Fn. Okay, so many people make it wrong. They think that okay, it can be greater than Fn. No, this particular term is actually strictly lesser than Fn. Okay, I mean if some function is equal to this, then it is strictly lesser than Fn. So if something lesser than Fn I'm adding, I don't think it may impact anything. So that's why it is theta. So hence it is true. It is true. Okay, great. Now let's see this. This is true, right? This is true. Okay. Now can you answer this question? If Fn is equal to order of Gn and Fn is this, which means it is lesser than equal to, greater than equal to, then definitely it is theta first of all, right? Then this is theta. Then which means Fn is theta of Gn. If this is theta, then the square is also theta. What do you think? See, just see if the constant can play any role. The constants can't play any role here, right? So we have seen this. So that's why this is true. This is true. What about this? This. Then both are equal. I think we have seen this also, that both are theta, not equal, right? So that's why this is false. Right? This is false. Okay. Can you rank the given function in the order of the growth? This is little interesting question. Can you rank this? This n factorial power 1 upon n and log n power n. Let's just take log. If you take log, then what is happening? This will be 1 upon n log n factorial. This is already n log n, and if you take the log, it is log of log n power n, right? So if you take the log, it is log n factorial, which is same as n log n. Okay, after taking the log, actually this is same. This is same as n log n. So if you put this as n log n, then n will get cancelled out. This is just log n, and here you are getting log of n power n, which is same as log of, this is n log n, so log of n plus n log n, right? Log of n plus log of n. So this is log n plus log of n, and this is log n only. So now as you can see, asymptotically both are same, right? After taking the log, we have seen that after taking the log, both are coming to be same. Then what you can conclude? You can't conclude here, right? If after taking the log, both are coming to be same, then you don't know basically, right? So here, after taking the log, you have observed that if you take log, then it will be 1 upon n log n factorial. It is log of n log n, right? This log n factorial is exactly same as, I mean theta, obviously theta, right, is same as n log n. So asymptotically this is same, n log n. So this will get cancelled out. This is actually log n, and this is log n plus log of log n. So actually both are same, asymptotically both are same. So after taking the log, both are coming out to be same. So that's why you can't comment anything. Now what you can do, if you can't comment anything, let's just see if you can do something, okay, some other trick or something else. So here, this is n factorial power 1 upon n. I just wish that it could be n power n, right? I mean, see, if this is n power n, let's suppose, can I write this n power n directly? Obviously no, because both are not same. But let's suppose if I write it n power n, then let's suppose what is happening. Let's see what is happening. This will be n, this is n log n, right? So see, if I write it as even bigger function, if I'm writing, then also it is strictly greater, right? It is strictly greater. So you can say it is strictly greater. This log n power n is strictly greater than, even if I'm writing bigger function here instead of n factorial, even if I'm writing bigger function, it is strictly greater. And I know that this is strictly lesser than, or this n factorial is strictly lesser than this, right? So I already know this. Okay, so that's why what you can say, because of this transitivity, right? Because of this transitivity, what you can say here that in between these two functions which I want to compare, basically in between these two functions, right? N factorial power 1 upon n and log n power n, this is greater, right? In between these two functions, this is strictly greater. Okay, so here what I did, I first took the log, but after taking the log I realized that I can't conclude anything. Then I am just seeing that if I can do some other trick. Okay, if I can play some other trick. Now it is basically up to the question. Now I mean, that won't be too difficult to play any other trick, but here the trick that I'm playing, okay, I just observed that, okay, what if it is, I'm just putting is n power n. Okay, I'm even putting the bigger function here. Even after putting the bigger function, I realized this is n log n, this is n, right? So even after putting the bigger function, this is still greater. Then obviously this is still lesser. I mean, this is definitely lesser than this function, right? Okay, see here that if you take the log both side, then after taking the log, both functions are coming asymptotically equal, hence we cannot conclude using this method. Then I just have some other method, which is, let's suppose, method 2. Okay, and this method is basically saying that you putting even greater function in place of n factorial, which is n power n. Okay, yeah, that is a nice question. Now let's just see some of the gate PYQs. Okay, let's just see some of the gate PYQs. Let's see this particular question. So what they're saying, which of the following statement is true in all the positive functions fn? So is A, B, C, D. Can you tell me which of this is true? So this question has been asked in 2022. What they're saying, that you take the positive function fn. So see, can you say that fn square, let's just go to the next page and let me just ask you the question. Can you say that fn square is basically theta of this particular term? What do you think? Theta of fn square? If it is, the given function is positive function, right? So they have not said this is increasing or decreasing. Can you tell me? Just take some decreasing function. I think it will be easy, right? If fn is this, okay, if fn is this, let me just first solve for a. Okay, I am solving for a. If fn is this, then fn square will be 1 upon n square. Okay, they are still theta. Okay, so this is not working. I mean, this particular example might not be the very good example here, but let's just see if there is some other example, some counter example we can take. Okay, so sorry, they are saying that is polynomial function. Yeah, okay, I haven't tried it. Okay, they are saying this is polynomial function. If it is a polynomial function, then what will happen? See, this is saying whatever the polynomial function you take, right? Whatever, like n cube or n cube plus n square, whatever the polynomial function you take. Now, the moment you put, this n as n square, basically in the polynomial function, first of all, you can always ignore the other terms. You can always take the most significant terms, right? So let me just take it as n cube. Now in the polynomial function, you keep it as a n square, or you take the whole power, right? You keep it as n square power cube, or you put the whole power. Then in the polynomial function, both are same, because it depends on the highest degree. Here the highest degree will be same, and here also the highest degree will be same, right? The highest degree will get multiplied by 2 in both the cases, which means earlier it was 3, here also it is 6, highest degree is 6, here also highest degree will be 6. Okay, so that's why this is true. What about B? What do you think about the B? What this b is saying? B is saying that f of n square, f of n square is equal to small o of f of n square. Okay, for some function, which means that if fn is given to be any positive functions. Okay, so which means that f of n square has to be strictly lesser than f of n whole square. Okay, f of n whole square, it has to be strictly lesser than f of n whole square. What do you think? Can you think about some counter example here? See, if you take let's suppose log n, right? If you take log n, then it will be just log n, right? It will be just f of, and if you take just log n, now this is log n power square, this is log n square, right? I mean log n whole square. It is still log n. It is basically log n into log n. So yeah, this is greater. I mean this is definitely greater. If you take log n, it seems like it is greater. But can you think about any other function? So see, if you're taking the log n, then it is coming out to be log n square, right? It is coming out to be log n square. It is coming out to be log n whole square. Then obviously log n whole square is greater, because this is nothing but log n, and I mean 2 log n. This is log n into log n, right? Then this is greater. So it seems like it is greater. But is this always greater? Can you think of any function where it is not greater? Just think about it. Can there be any function where this b can be false? See, in the log it is seeming like it is not working. But you take any other example, for example 2 power n. Just try with 2 power n. See, let's just try with other function, which is, let's suppose 2 power n. Okay, so it is enough to try with log and exponent. I think log and exponent cover a wide range of possibilities. So you can try with 2 power n. So if let's suppose fn is 2 power n, then fn square will be, f of n square will be 2 power n square, right? And what about f of n whole square? This will be 2 power n square, which is nothing but should I be writing as 2 power n square, or should I be multiplying these two? I should be multiplying, right? So it is basically 2 power n into 2 power n. I mean 2 power n into 2 power n, which is nothing but 2 power 2n. So now you tell me in between 2 power n square and 2 power 2n, which one is greater? Obviously n square is strictly greater. Even after taking log, the n square is strictly greater, right? Even after taking the log. So this is 2 power n square. So this is strictly greater. So that's why this is false. Okay. Even after taking the log. What about C? What about C? Let's just check. What about C? So here they are saying f of n square is basically, here they were saying strictly lesser. Here they are saying lesser than equal to. Okay. F of n whole square. See, f of n square we have seen, if you take 2 power n square, it is 2 power 2n. We have seen this is strictly greater, right? Since it is strictly greater, that's why C is also false. C is also false, right? We have seen, I mean for B and C we have the same counter example, right? So C is also false. What about D? What about D? What do you think? Okay, in C even they have given the exponential. Okay, this is an exponential function. This is a good hint. What about D? Can I say that f of n square is greater than or equal to f of n whole square always? What do you think? Just think about it. So we have taken the log, right? Let's just take the log. So for the log, it will be log of n square. It will be log of n whole square, right? It will be log n. I mean 2 log n. It will be log n into log n. Can you say it is greater than or equal to? No, right? So that's why this is also false. Okay, you can take the exponent and log and just see if this is true or false. Mostly it will cover all the cases. Okay, so D is false, right? So only answer is A. Only answer is A. Okay. Now, can you solve this question? This question has been asked in 1994. So what they are saying that before 10,000, this is NQ. After 10,000, this is N square. See, for us, it doesn't matter that what is happening with the smaller values. Smaller in the sense that doesn't mean that 1, 2, 3. I mean, any theoretical value, okay, could be smaller value, which means that if they are saying 10,000, then after the 10,000 matter to us, which means that after 10,000 it is N square, right? So we should be taking care of the higher values. Okay, it is N square, and after 100 it is N cube. So which is greater? So see, you can write G1 as in fact N square and G2 as N cube. Okay, I mean you can say it is N greater than 10,000 if you want, but that's fine. This is also N greater than 100, but you can also say N greater than 10,000, right? Okay. Now this is very easy question. So basically this G1 is G2O, right? Since this is O, so that's why G2 is G1O, no. Okay, G1 is order of n cube, no. G2 is order of n, no. So I think only A is the correct answer. Sorry, there's A and B. G1n, yeah, sorry, this is order of n cube. So G1n is order of n cube, yes. So because this is G2 is in fact theta of n cube, right? So you can say G2 is theta of n cube, and G1 is definitely n square, so order of n cube also. Okay. G2n is not this order. G2n is big O of n. No, G2n is in fact n cube. Okay. Can you solve this question? This question has been asked in 1996. So what they are saying, which of the following is false? See, let's just compare. Let's just compare all of this. Okay. Let's just see which of the following is false. Now they are saying here, they are saying this 100 actually won't matter. This is n log n. This also 100 won't matter. This is definitely true because both are same, right? What about this? What about this? Let's just assume that log n is k or something, okay? This is k, I mean k power 1 by 2. This is basically, let's just compare k and log k. So as we know that k power anything or n power anything or anything, it is basically strictly greater. So this is strictly greater even, right? So this is definitely false. This is not lesser than equal to this. If by is greater, then this is, yeah, that is true, right? We have seen this. So 2 power n, let's just compare between 2 power n and n into k. So it is just n, right? I mean, if k is a constant, then this is just n. Then obviously this is not the relation. So that's why this is also true, right? This is not the relation. So that's why only B is false. Okay. B is false. Let's just see this question. This question has got good upvotes, 76 upvotes. Let's just see this question. Okay. Is this visible? So they are saying, let's just consider this function. Okay, fn, gn, and hn. Now they are saying which of the following is true. Okay. let's just arrange them. Okay, arrange them in the increasing or decreasing order, right? So let's just arrange them in the order, and then we can see which of the following is true. Now one option is n factorial, another one is 2 power square root of n log base 2n. Okay, this is gn, this is n factorial, this is 3n power n. So I think this 3 won't matter, so I'm not writing it. This is n power square square root of n and n factorial. So let's just compare between these two first. Okay, let's just compare between ns power this and n factorial. Let's just compare between these two. Now, if you take the log, it will be square root of n log n. It will be n log n, right? I mean, this is theta, right? This is basically log n factorial is same as n log n, exactly same. I mean theta, right? This is exactly theta. So I can write like this. So log n will cancel out. So this is strictly greater. So I can say n factorial is strictly greater than ns power n. So I can arrange them in an order. I can say it is strictly greater. Okay. Now let's just see the third function that we have, which is n 2 power square root of n log n. Okay. This is the third function that we have, which is 2 power square root of n log base to n. Maybe I can compare this with again n factorial. Let me just compare with the n factorial. You can compare with anything. Maybe you can compare these two. Let's just compare these two. So it will be root n log base to n. It will be root n log base to n. Okay. Yeah. If you take the log, it will be outside. If you take the log, this is yeah. I think both are same. So you can't say anything, right? After taking the log, both are same. So you can't say anything. Maybe I can just compare these two. Okay, let me just compare these two. So see, after taking the log, I can't say anything. So I'm just trying to compare these two. If you compare these two, it will be after taking the log, it is something like this, and it is n log n. So definitely this n factorial is greater, right? So this n factorial is definitely greater than this quantity also. So let's suppose this is ABC. So basically you can say the relation that we are getting is something like this, that n factorial is greater than 2 to the power square root of n log base to n. Okay. So by the way, this 2 to the power square root of n log base to n, can you not write this? 2 to the power log base to n square root of n. I mean, can you not take this as a power? Definitely. And if you remember the property of log, if this in exponent and base is same, then this is nothing but ns power root n, right? So basically, in fact, they're exactly same, not even theta. This thing, okay, this thing is exactly same as n square root of n. Okay. So n factorial is even greater, is strictly greater. So what is the answer? Hn, no, Hn won't come in the big O. So Gn is not order of, no, Gn and Fn is same. Fn is order of Gn. Yeah, Fn is order of Gn, right? In fact, they're theta. So you can say that in terms of asymptotic comparison, you can say this, right? So in fact, they are theta basically. Okay, they are theta. Ideally, I should be writing like this. Ideally, I should be writing the theta here, and then this can be I can write C or something. So anyway, asymptotically they are like this, that these two are asymptotically same. This is strictly greater. So I think D is the correct answer. Right? Easy question, but only thing here is that you can just see that okay, this thing and this thing is same. Okay, so let's just see the answer. So D is the correct out of all choices. Okay. So by the way, do not take the large values of n, because it might confuse you in the exam. Just use the method which we are discussing. Okay. Now can you arrange them in the increasing order of the asymptotic? See, if you notice, then this E. Okay. This basically E, the option E here is increasing function. If it is a decreasing function, then it is the lowest one. But just because it is increasing, it might play some role. Okay, can you arrange them? Let's just see. This is so they are saying increasing order. Okay. So this is ns power something, this is n power something, this is, I think this bn will be the largest one. So D is anyway rejection. Okay, D is anyway rejection. Now, in between ns power 1 by 3, ns power 7 by 4, which one is greater? See, 1 by 3 is greater or 7 by 4 is greater? You can just check with the power. Let me multiply 4 here. It will be 4 by 12. It will be, let me multiply 3 here, 21 by 12, right? Sorry, 21 by 12. so which one is greater? 7 by 4 is definitely greater. It is even 1 point something, right? 7 by 4 is definitely greater. If 7 by 4 is greater, you can definitely say C is definitely strictly greater than A. Okay. So A and then C, and then C, and then C. Okay. So that's fine. Now B is anyway at the last. Okay. What about N? N into log N power 9 and N into 1 by 3 N power 7 by 4. See, this is something greater than 1, right? So this is something greater than 1. So if you just cancel them out, then this will become log N. See, this is very, very nice question, right? Let me just go to the next page and let me just ask you this thing. Among these three. And then what is the last one? N into log N power, let's suppose 9. Among these three, which one is greatest? See, this is greatest. Why? This is basically N into N is power some epsilon. I mean, it will be some positive power, right? Obviously, like 0 point something could be there, but it will be some positive power. I mean, it is basically 1 point something, right? Okay. So if I just even do this is 1.75, right? So, I mean, you don't need to do this that much, but I'm just telling you that if you do it, this is 0.75. Okay. Now this is N is power 1 by 3, which is lesser than 1. This is N is power log N power 9. Obviously, it is lesser than 1. So that's why this N is power 1 by 3 will be lowest one. And then among these two, you can cancel them out. You can see that N is power any small power is greater than log power anything, right? So that's why this thing will come next. And then N is power 7 by 4. Even they are strictly greater, okay? There is no even equal symbol, which means they are big O. Okay, so here you can say the relation is this, right? The relation is this. So you can say that N is power 1 by 3, which is A, and this is D, this is C, CDA, right? So C is, sorry, I think I put a wrong symbol. It should be greater. Okay, here I should be putting the greater symbols. Just a second. Okay, it should be greater symbol. This is greater, this is greater. Right? Now what we should do? We should say that this N is power 7 by 4, which is basically which is the greatest function. So C is the greatest one, and then between C and A there is a D. So you can in fact write that B is here, between C and A there is a D. Right? Now A, B, C, D, I think E is the only remaining. This is some exponent. So this is anyway the greatest one. So you can say this is the order, right? A, D, C, B, E. A, D, C, B. A. Yeah, A is the lowest. Okay, B is e power n. Sorry, B is e power n. Then if B is e power n, then in that case, we need to compare this e power n and this function. So which one is greater? See, this is 2 point something, right? 2.7 something power n. This is 1.0 or something power n. So definitely, which one is greater? See, you need to compare between e power n and 1.0000 whatever it is. Okay, power n. You can definitely divide by this, right? If you divide by this, it will be e upon 1.000 something, right? Something power n, and this will be just 1. So obviously this is an increasing function because it will be more than 1. So that's why this is definitely greater. So e power n is definitely greatest, right? E power n is definitely greatest. So B will be at the last, and then this E will be in the between, right? E will be in the between. So A, D, C, E, B. Okay, A, D, C, E, B. So that's why A is the correct answer. Yeah, A is the correct answer. Understood? So hence you can say A is the correct answer here. Okay. I hope you understood. The only interesting part actually here, the interesting question I can say, I like this, right? I like this. So here the multiple concepts are involved. So what are the multiple concepts here? What are the multiple concepts I'm talking about? The first concept is that if you have if you have n's power something which is a greater power, then you can definitely arrange like this. You can definitely arrange like this if you have greater power. And the next concept involved is that n's power any epsilon or anything is actually greater than log n power any bigger power, right? So that's why this particular term, which is n log n power 9, it is even lesser than this n's power 7 by 4, right? So that's why this will come in the between. Okay, so here the symbol is greater symbol. Okay, okay, okay. Now let's just move to the next question. So this question has been asked in GATE 2004. So what they are saying, let's just see. Okay, let's just see what they are saying. Fn, Gn and Hn be the functions defined for positive integers such that Fn is this, Gn is not this, and Gn is this. Okay, and Hn is this. Now they are asking. Okay, so they are saying that Fn is lesser than equal to Gn. Okay, I mean I should be writing C into something, but I'm not writing it, but that's fine. Okay, and Gn is not related to Fn. I mean Gn is at least not lesser than equal to. Maybe greater, may not be any relation, right? You don't know actually. Gn and Fn are they have not given any relation. Gn, they are saying Gn is lesser than equal to Hn, and Hn is also lesser than equal to Gn. So using this two, you can definitely say both are theta, right? Both are theta. So you can say both are theta. So this is the relation that they have given, right? Okay. So they have not given any relation between Gn and, okay, they are saying Gn and Fn are related like this, and they are not related like this, which means that the theta is not possible, right? So that's really interesting. See what they are saying. If one function is Fn, which is big O of Gn, another function is, let's suppose I am saying Gn, they are saying this is not equal to big O of Fn, then what does this imply? Can anyone tell me? It means, see, they have given two things. One thing is they have given something like this, and another thing they have given something like this. Gn equal to order of Hn, and Hn equal to order of Gn. Another thing they have given something like this. See, if they are saying that both are related by big O, then it means both are theta. Gn equal to theta of Hn, right? Both are theta. If they are saying one is lesser than equal to, and another one is not lesser than equal to, it means definitely they are not theta. Then what does this mean? They are small o. Even they are small o, right? You can say Fn is small o. Can you say something like this? Small o of Gn. Why? Because they are eliminating the possibility of theta, that they cannot be theta. They are saying that this is lesser than equal to, but this is not lesser than equal to, right? Which means it is strictly lesser. Okay. So which means you can say Fn is strictly lesser than Gn, and then Gn and Hn are equal. Okay. So Fn is strictly lesser than you can comment here, and Fn and Gn and Hn are equal. Now you tell me which one is the correct answer here. Okay, now you tell me which one is the correct answer. Now they are saying if you add both of them, Fn and Gn, if you add both of them, actually this is greater, so this will be just Gn, right? This will be just Gn. Now will this be the correct? Yeah, so this is Hn, even their theta, so this is correct, right? So this will be the correct answer. So they are saying false. Since they are saying false, this is actually true. This is true. Why? Because this term is nothing but Gn only. Okay. Fn and Hn are related like this. Is this big O possible? Yes. If small o is possible between them, then big O is definitely possible. So that's why this is also true. What about this? Hn is not of, Hn they are saying is actually, as we know that Hn is greater than Fn. Now they are saying Hn is not lesser than equal to, which means it could be greater. I mean it is greater basically, right? It is greater. So if it is not lesser than equal to, then maybe they are incomparable, but as we know that they are greater, then yeah, that is true, that not lesser than equal to, right? Because Hn is greater, so that is also true. What about this? See here what I'm saying here, Hn is not lesser than equal to Fn. That's what they're saying. Yeah, that's true, because Hn is in fact greater than Fn, right? So that's why this is also true. What about this? Fn into Gn. So Fn into Fn into Hn. Okay, Fn is some function. Okay, it could be any even decreasing function, right? Because if it is into, then I need to check whether it is increasing or decreasing. So it could be even decreasing function, right? It could be any function. Is not equal to Gn into Hn. So let's just see this. Let's just see on the next page. So what they're saying, that the given relation is Fn is lesser than, okay, Fn is lesser than Gn, which is equal to Hn. Now from here, what can you say? Fn into Hn. Fn, which is a smaller function, into Hn. Here they are saying is Gn into Hn. They want to compare these two. So Hn will definitely get cancelled out if you compare these two. Then you want to just compare Fn and Gn, right? Fn and Gn. Now they are saying that this less than equal to is not there. In fact, it is greater. If less than equal to is not there, then as we know that it is basically in fact lesser, they are saying less than equal to is not there. So that's why this is false. They are saying this is not there. Actually, this is there, right? This is there. So hence this is false. So this is false. Okay, answer is D. Yeah, can you solve this question? If Fn is n, it is ns power 1 plus sin n. Okay, I hope this is visible to everyone. If that is the case, then what can you say? What can you say? Which of the following is or correct? See, can you compare between these two? The answer is both are incomparable, right? So that's why neither one or two. Okay, neither one or two. So that's why D is the answer. See, if I just ask you, can you compare between n and s power 1 plus sin n? Then since this value, this power can be sometimes lesser than 1, can be sometimes greater than 1. So you can't compare, right? Can't compare. If I ask you, what about this? 7 plus sin n, then what is your answer? See, this power is always greater than 1, right? I mean, this particular power, this sin n can be between -1 to 1, but this particular power is always greater than even 6. So that's why this is strictly greater, okay? Then you can compare that this is small o of n power 7 plus sin n. Then you can definitely compare. Understood? If it is 1 plus sin n, you can't compare. What if it is something like 7 plus sin n or something? Let's suppose I ask you, can you compare? Can you compare 2 plus sin n? What about 2 plus sin n? Then you will say sometimes if sin n value is 1 minus 1, then sometimes it is even 1. So that's why you will say it is lesser than equal to. Then you will say n equal to big O of n is power 2 plus n. Sometimes equal. It could be equal also actually, right? Big O. Understood? Now let's solve this particular question. Let's see if you can answer this question. Okay, let's solve this question. Consider the following three claims. N plus k power m theta of n power m, where k and m are constants. Okay, so one is n plus k power m and this is n power m. So see, this is a polynomial, right? Can you tell me the degree of this polynomial? By the way, first of all, tell me, can you ignore this k? Can you ignore this k? If k is constant, can you ignore this k? No, right? It is you can't write it k into some function, right? Or maybe k plus some function. Since you can't write it, you can't directly ignore like this, okay? So just be aware about it. What about degree of this function? it will be ns power m only, right? It will be ns power m. Obviously, it can't be greater than s power n. This is ns power n. Both are theta. Yeah, I think that is true, right? This is okay. What about 2 power n plus 1 and 2 power n? This is 2 into, see, this is 2 power n plus 1 and 2 power n. If you compare these two, you can say this is 2 into 2 power n, this is 2 power n. Then this is constant, right? So theta, right? This is actually theta. So in fact, this is theta. So that's okay. What about 2 power 2n and 2 power? So what about 2 power 2n plus 1 and 2 power n? See, if it is 2n plus 1, then you can say this is constant, but you can say this is strictly greater, right? You can divide by 2 power n. So see, this is basically constant. You can ignore this constant and then you can divide by 2 power n. If you divide by 2 power n, this will 2 power n, this will 1. So this is strictly greater. So this left term is strictly greater. So that's why this is false. So I think 1 and 2 are true. 1 and 2 are true. So A is the correct answer here. Understood? Okay. Okay. So this is all I wanted to discuss. There is one more question. If you want, you can take it as a homework. Answer is on the next page. Okay. Answer is on the next. So that is all we wanted to discuss today. We have discussed the complete chapter on notations, right? Asymptotic notations. If you have understood everything very well, if you have solved all the questions, we have solved all gate, okay, all gate PYQs, tricky questions, okay, tricky questions we have solved. We have solved many standard university questions. What else? What else we have done? We have basically, you can say, we have even touched basic definitions of notations, right? Basic or core definitions of the notations. Yes, I will immediately put the annotated notes in the comment. Okay, the annotated notes you can find in the comment. Yeah, immediately I will put it. Okay. So if you have liked this session, if this was the complete a good revision, if it is a good revision, just comment. Okay, just comment that how you felt about it. If you felt that okay, it was a complete the thorough revision of everything in terms of the notations, then please comment and let me know. Okay, tomorrow we will discuss the loop complexities, the master's theorem proof, okay, master's theorem proof and many other things. Okay, master's theorem proof and many other things related to this asymptotic notations. Today I just wanted to touch the asymptotic notations and their increasing order, decreasing order of the functions. Okay, just please comment it out. Okay, please comment it out and let me know how you liked it. Okay, if you have loved the session, just let us know if you loved it. Okay, just please comment it out so that we get motivated. Okay, cool. So thank you everyone. Take care. Bye bye. Yeah, thank you everyone. So if there is any other doubt, okay, if you have any doubt, just comment it also. Okay. Thank you everyone. Take care. Bye bye.